My name is Jake. My name is Jake Worth, and I'm here today with my colleague Jack Christensen, somewhere in this sea of faces, and we're here to teach some SQL today. I'll start off by introducing myself, and then I'll let Jack do the same. My name is Jake Worth. I'm a web developer and veteran. I served in the Army from 2005 to 2010, deployed to Iraq in 2006 and 2008 as a tank platoon leader and scout platoon leader. And then I made a transition into web development, and I've been programming for about 10 years. My connection to Code Platoon was that I also used to live in Chicago, and I got involved with a alpha cohort and started teaching with that cohort, and have been teaching with them ever since, and then also doing mentorship. So that's what brings me here today, and I currently work at a company called FrameBridge, who has sent me here today in the tradition of Hash Rocket. So yeah, that's my background. Jack, would you like to give us a little intro?
Yeah, sure. So my connection with Code Platoon is through Jake. So Jake mentioned Hash Rocket. That's a web development consultancy we both worked at. And when the first cohort, Alpha Platoon, was starting, Jake was kind enough to invite me along. And we've been doing it ever since. I've been doing development for probably about 20 years now. And I'm looking forward to sharing some SQL. I think it's probably it's one of the most fun parts of software development and one of the most valuable.
Early on in the day, we usually go around and have everyone introduce themselves. This group is way too big for that, which is a testament to the power of Code Platoon and everything Rod has done. So, and you all know who you are. We're the only ones who don't. So I'm just going to drop my LinkedIn in the chat. And if you all want to connect with me there, that would be awesome. I have, over the years, gotten to know a lot of the people who are in these sessions later. So that's why I thought of that. And, Jack, you can do the same, or however you want to be contacted. We're also always in the Code Platoon Slack for now and in the future. Okay, I'm going to switch over.
You can get me on the Code Platoon Slack. I've studiously avoided like social media, much to the chagrin of my business partners. I'm like not on LinkedIn or anything like that. So yeah, Slack is the best way to reach me.
Cool. Okay, I'm going to switch over to sharing my screen, and we'll get started. Okay, can you all see a terminal and some text editor here?
Yep.
Cool. All right, so this is the agenda inside that SQL workshop repository that I posted in Slack a couple days ago. If you missed that message, we're going to start in doing stuff in this repo in about an hour. So between, and there'll be a little break as well, like a 10-minute break. So you can, between now and that time, or on the 10-minute break, you can go and find this repository and pull it down. But I'll talk a little bit about why you might want to do that earlier rather than later. This is a plan for our workshop. 9 a.m. Central Time. We'll be doing getting to know each other a little bit, and a reading review. And that's what I'm going to start here in a minute, looking over the assigned database reading. Then from there, oh, cool, thank you. From there, it's going to be closer to 10. We'll start doing SQL at the Postgres REPL. REPL stands for read, evaluate, print loop. It's when you're in a terminal and you're typing stuff, and then a program is giving you something back. So we're going to create a database, and we're going to add to it. the way Jack and I approach SQL is to just do SQL. There's a lot of different layers on top of SQL, which we'll talk about, but the timeless thing and the thing that they're all abstractions of is SQL. So we just go straight to the SQL and we type it into the REPL, and we think that's a really useful way to get some of these concepts. So these are the concepts we'll be covering in the morning. And over in that README is instructions for setting up. So you want to clone the repository. You want to make sure you have Postgres installed. I think that's a preliminary step to the whole bootcamp, but it's the foundation for today. So make sure you can access PostgreSQL through the command line. I gave a couple examples of commands you could run just to demonstrate that you had that. A couple pieces of just general advice for all this stuff we'll be doing today. First is that instead of copying and pasting, try to type out the commands. Now, when Jack and I are actually going through these exercises, we will be copying and pasting because it isn't useful to watch us make mistakes. But it is useful for you to learn how to type fast and also to memorize these commands. So if you can, try to type them out. There's also a feature in most REPLs called tab complete, which is you start typing a command, you hit tab, and it tries to finish it for you. That's a really good skill to learn. Second, always make your terminal window as big as you can, like have it fill up your screen, however big your screen is. Code should always be easy to read. You know, if you can't read it, make the font bigger. If you get stuck, let us know. Jack and I both want you to succeed. So we're going to take turns teaching. When Jack's teaching, I'll be available to help, and vice versa. Okay, number one debugging tip, read the error message. The answer is almost always on the screen. It's sometimes just really hard to see. And finally, please ask questions. You can ask questions of either of us in Slack, or during the breaks, we can also answer some questions. If something doesn't make sense to you, it probably wasn't explained well enough. Okay, so then we'll have a 12 o'clock lunch, and then we'll continue in the afternoon with more advanced exercises. At 3, we'll be doing a data modeling exercise, which I'll be leading. And then we'll wrap up around 4 with some Q&A, and then turn back over to your instructors. Any questions about the agenda? See some chats. When I have full screen, I sometimes don't see the chat. So, okay, great. I'm going to stop sharing and get the slides set up. Are you all seeing slides and not slides with notes?
Just the slides.
All right, good, because I read a lot of notes. That's the only way I can remember what I want to say. Okay, so I'm going to do a quick presentation here. It's going to take about 30 minutes. This is going to cover the intro to persistence reading that you were likely assigned, and then we'll take a break and get into the actual SQL. Okay, so we're going to start off. I'm going to start off today by reviewing the database reading. This is more pretty conceptual material as opposed to the rest of the day, which will be very practical. But I think it's a good way to start. So I'm going to lead off with an opinion that Jack and I share, that we I definitely honed in my years working with Jack. And that is that databases are important. Databases have a lot of business value. In some companies, that's like the most valuable thing that the business owns. They're also very sensitive, or they can be very sensitive. They can have personal information or information that you wouldn't want people to have access to. Databases will outlast almost all the other code in your application. You're going to rewrite the application probably multiple times, but the database will most likely just be sitting there doing its job. So we think databases are important, and we are very excited to be here to teach you about them today. So the reading talked about databases from 4 steps, from 4 angles. The first is persistence. What is persistence? Why do we need it? The second, we look at a common solution to persistence, which is the spreadsheet, and try to think about why it isn't the way that data in a web development is stored. Third, we'll talk about relational databases, which is one approach to the database problem. And fourth, we'll be talking about RDBMS, which stands for Relational Database Management System, which is a collection of tools that come with modern databases. If you have questions about any of this, jot it down. We can talk about it throughout the day, or feel free to interrupt me too. So as I said, this will be about 30 minutes and about 30 slides. Okay, part 1, persistence. Would anyone like to offer a working definition of the term persistence?
Something that doesn't go away.
That's awesome. That's probably the most straightforward answer I think ever. Something that doesn't go away. I like it. Yeah. I can't see anybody. Thank you. Persistence. Yeah, this is from the dictionary. Continuance of an effect after the cause is removed. And this kind of alludes to an idea that is really important in computers, which I define as data is transient. Data in computers, it only lasts as long as we tell it to last, and it doesn't last any longer. It doesn't have any intention to stick around. A couple of examples of this that come to mind for me. One is scope. So what I've written here is an anonymous JavaScript function using the ES5, ES6 syntax. So it's like a sum function, right? It takes an argument A, an argument B, and it adds them together. When we call this function with the 2 arguments and the 2 things are added and returned, what happens to A and B inside of that function? Well, they have scope. They have something called scope, which is their scope is the function that they're in. And when that function isn't being used anymore, or eventually the language comes along and gets rid of them through a process known as garbage collection. So the data that they were holding on to is gone. It's wiped away. Another example is memory or RAM. RAM is holding information, but when its power supply goes away, it loses that information. So turn off the power supply, information goes away. Data in computers is not like designed to just hang around. If we want it to hang around, then we have to tell it that we want it to do so. And these are some of the tools we use to do that. So first we have databases, or some people call them data stores, sort of the focus of today. The second is SQL, which a lot of people pronounce as SQL. Structured query language, that is the language for interacting with most databases. Then we have the RDBMS, the Relational Database Management System. And then finally the ORM, the Object Relational Mapping. have you all gotten into Django ORM at all yet?
Yep.
In a bit, like very basic.
Yeah. Would anyone can anyone try to summarize or say like what an ORM is?
So, I mean, we have gone into Django a little bit, but we haven't gone into ORM yet. I believe that's going to be next week for us.
Cool.
That's right.
Yeah, that's my bad. Objects, not the relational mapping.
Awesome. So ORM's object relational mapping, it's an abstraction of SQL. It's a way for you to write SQL in a language of your choice. I believe the Django ORM is called Django ORM, or the Python ORM for Django. In Ruby on Rails, it's called Active Record. There's lots and lots of ORMs. Phoenix, Elixir Phoenix is called, I don't remember. It's a way of talking to SQL in your language of choice. And it's an abstraction of the database layer. We're not going to be talking a lot about ORMs today. And that is, that's a decision, that's a choice. ORMs are a really big part of professional work as developers. Most teams, when they're writing SQL, I think are writing in ORMs and not generally in raw SQL. But as I mentioned a little bit earlier, the thing that they're an abstraction of is SQL. So if you understand SQL, you have knowledge that sort of transcends whatever framework you're in. And I think that's Jack and I both think that's a pretty timeless way to approach this material. Okay, back to persistence. The continuance of an effect, because data is always going away. So now I'd like to look at a way we could store data, which is spreadsheets. Always with military folks, you have people who did a lot of spreadsheet work. Some people call Excel the world's most popular programming language, which I think is interesting. To understand what a database is, it helps, I think, to look at databases from a different angle and to try to understand what they replaced. The thing I'm talking about is called a ledger, or the more modern version is a spreadsheet. So there's this book that I read early in my programming career called The Manga Guide to Databases. It's got a really silly cover. I always feel embarrassed putting this up in the talk, but it's the perfect book to make this point.
You're in the right group for this.
Well, it's a good book and it teaches good lessons and it's well written. So this book is set in a magical kingdom that's trying to design a system to track its fruit business. And the fairy on the cover teaches the kingdom how to organize their fruit business data, starting off with something called a ledger, that brown book on the cover. And then they keep using the ledger and they inevitably arrive at the conclusion that it's not the right tool for supporting their business. And what they slowly migrate to is a paper version of a relational database. What I think this book does is it presents a classic thought experiment that many people go through or went through when they're learning about databases, to point out sort of step by step why a spreadsheet isn't the right tool for every kind of job. We're not going to go through this experiment today, but we will look at a spreadsheet and talk about it because the concept of a database came from somewhere. And I think that spreadsheets help us understand that. So this is a random spreadsheet that I got off the internet a long time ago. It's just used to track money, financial information. What would be like the job title of a person who is using this spreadsheet every day?
Accountant.
Okay.
Yeah, okay, like an accountant or an analyst. So it's like a specialized person. It's not just not just anyone is even allowed to touch this thing. As a data storage tool, can anyone think of, well, let me talk through what is kind of missing here, how this could fail to be useful. Actually, let me flip that around. Would anyone like to suggest some like limitations of this as a way to store data?
Well, it's a little more difficult for multiple people to access it, or those who need to access it and make changes to take that data and use it in other applications.
Yeah, great point. Multiple people accessing it is a problem. I think Excel has tried to solve this in a number of ways, but it's always a problem. What else?
It's awkward to actually make changes.
How so?
You got to go fish around for the right box and click in it and try not to click anything else. And it's just delicate.
Yeah, it is delicate. Lots of opportunities to make a mistake, right? Like cat walks across your keyboard and you just like jacked up a year's worth of data. Now that can happen in SQL too, but any other ideas?
The data doesn't link with each other. So like your cash flow doesn't talk to the balance sheets. Like there's no way to connect them. It's just all like there.
Yeah, it's all there. I love that description, right? Like the data isn't organized really. It's like it's just a flat collection of information. Okay, I'm going to throw out some ideas here that copy or mirror a few of these. What if a couple people want to use it at once? It might be able to do that. What about 100 people? Probably not so good. Online spreadsheets are probably better at this, but it's a persistent problem. It's probably not very fast, right? Like this is a graphical user interface program on your computer that has a lot going on. It has that ribbon, it has all the tabs and buttons and things that hover. It's not going to be the fastest program on your computer at all. It's not very searchable, right? People who are really good at spreadsheets use like pivot tables to slice the data into different formats and presentations, but that isn't very easily accessible to the average person. It's not presented very well, right? It's like just a flat list of information. It's hard to restrict access to this. I think you can do that, but online spreadsheets have tried to tackle this, but it's hard to say this person on my team is allowed to change these things, or this person can just read the whole file. Error prone, right? You just click on a cell and you're just typing. There's nothing really stopping you from messing up the data. It's just a file on your computer, so it could get corrupted. If all the files on your computer get corrupted, this one could be damaged, and then you can't ever open it again. You can't connect to it remotely. If I put this on a server inside of a warehouse somewhere, I don't believe there's a way for you to edit this file from your computer. At least there's not an easy way to do it. So this is a lot of things that spreadsheets don't do very well. And the data on the spreadsheet's really important, so that's a problem. It's just not optimized for these lists of problems, and the list of problems that I just threw out there are web development problems. It's also it tries to be really smart, like any Microsoft program. It will, if you import data via CSV into this, it's going to make a bunch of decisions for you. It's going to coerce things into different data types and potentially ruin meaningful data. Okay, so this is a lot of reasons why a spreadsheet isn't going to work for most web applications. Any questions on that? Okay, on to relational. So hopefully I've sold you on databases as an idea. How should our database be designed? The solution we're going to present today is called a relational database. And a very common question when people are learning databases is, what about not relational databases like like Redis or Mongo or NoSQL databases? Aren't those good? Shouldn't we be learning those too, or should we be learning those first? Those kind of databases are very popular, and they solve different problems and continue to be worth looking into. But there's a really good reason to start with relational, and that is that it's very popular. It's a very popular design. This is a chart from the Stack Overflow 2019 developer survey, ranking the most popular databases when people had the opportunity to select all that apply. So in first place is MySQL. Second is PostgreSQL, which is what we'll be teaching today. Third is Microsoft SQL Server. Fourth is SQLite. Those four are relational databases. Only in Mongo do we get into a not relational database. So the top four most popular databases, and there's a correlation there, I think, with what people use every day for work, are all relational. So relational is really popular, and it is the dominant database model. The question I think I would ask then is why? The reason that relational is popular is that it closely aligns with a couple of popular ideas in programming that I think we should know about. Okay, the first is that users should not know how data is organized. Look back at the spreadsheet. If you want to edit this spreadsheet, how do you do that?
You gotta click and just enter information.
Yep, you just click on a cell and you start typing. It's the form to enter the information is also, as far as the user is concerned, the information. The software, Excel, it is the form. And when data is organized this way, the form has to reflect the way that data is stored, at least as far as we can tell. And that means that they're tightly coupled together. On the web, that is undesirable because we generally don't want users to know how the data is organized. There's a term for that, which is called leaking. We're leaking the database design to the customer. It's something they don't need to know, but if this was how we saved our data, they know it. Okay, second is that user activity should remain unaffected when the internal representation of data is changed. User activity should remain unaffected when the internal representation of data is changed. So imagine a company like Facebook. And let's just try to brainstorm, imagine how their data structure has changed in the last 15 years. What might a user in their database have looked like 10 years ago versus today? That data model is probably unrecognizable from 10 or 15 years ago, just because they're just constantly adding and doing things. But your experience as a user has continued along mostly uninterrupted. And from your perspective, it hasn't really changed much. Relational is great for this type of experience. Okay, so to demonstrate this, let's look at a relational database structure for an app that I built a couple of years ago at my old company, HashRocket. This app's called Today I Learned. It's like a blog for our developers about technology things that we've learned. So it's basically just a list of posts, and this is a post. Each post has a developer who wrote it, and it has a channel that it belongs to. It's a very simple database, and here is that structure. Okay, so this is something called a entity relationship diagram, ERD, and it's a common way of designing a database. So there's the three tables. As I said, it's really simple. There's channel, there's developer, and there's post. A post belongs to a channel. Channel has many posts. Same for developer. A post belongs to a developer. Developer has many posts. And this is accomplished through columns on the post table that map to IDs of those two tables. That's not shown in this chart because ERDs, they accomplish that by drawing those arrows. The arrows mean that. Okay, so the channel table, you've got a name and a Twitter hashtag. The developer table, it's got a whole bunch of fields, and then post, a whole bunch of fields, and so you've got the field and then its type. So if I made a form on the web to put a new developer into the database, all I want is to let someone enter a new developer. Would users from that form be able to know about posts?
Oh,
Unless I put it there, no. They wouldn't. If all I showed you was a form for developers, you wouldn't know about posts or channels, and you wouldn't be able to draw this picture. If I added a column to the developer table that I didn't expose in that form, let's say I have a field called "Is the developer cool?" and it's just always true, and I don't put that in the form, the user's not going to know about it. So that is, an example of the internal representation of the developer has changed, but the user does not know that. The developer and the channel table also don't know that the post table exists. The post knows that they exist, but they don't know that it exists. And they're connected through Ruby or Elixir, but at the database level, they're not aware of that table's existence or the other table's existence. So you can kind of look at each table like in isolation, and we're not leaking that design out to the users. There's a couple quotes that this has made me think of from a programmer named Sandy Metz. Sandy said, "Always delay making design decisions until you need to." We keep the table separate because we don't know what the final design is going to be. We might want to take these pieces and rearrange them, or get rid of some pieces, and that I think that's what Sandy was talking about. Another quote, Sandy's a great Ruby programmer. Her talks on YouTube are some of the best programming talks I think I've ever seen. She also said, "We'll never know less than we know right now." So we don't commit to a certain shape, and by not committing, we give ourselves the ability to change. So the relational model supports these two goals. Users should not know how data is organized, and users' activities should remain unaffected when the internal representation of data is changed. The way that we accomplish this is, or the tooling that supports this is called the Relational Database Management System. Okay, so this is these are the tools that support the database functionality, and it provides a number of features. You get a CLI interface, you get the ability to scale, which we talked about with spreadsheets. You get data validation. Something that, again, we said spreadsheets don't do very well. Data integrity and searching. let me talk briefly about each. So for CLI tools, there's a number of them. This is one, which is the REPL, where we're going to be spending most of our day. Again, REPL is read, evaluate, print, loop. The REPL for Postgres is called pSQL, and I've entered in this piece of code that I copied. I entered the Today I Learned database, which is called tilex dev, and then I ran a meta command /d channels, which is describe the channels table. And so then it printed out this output, and this matches what that table looked like back on the ERD. So you've got the ID, that was a hidden column in the ERD. It chooses not to show that. Name, Twitter hashtag, and then 2 more hidden columns inserted at, which is when the record was first put into the database, and updated is when it was last updated. Next to the column, we have the type, which is important information. Then we talk about whether it is nullable and whether there's a default value for any of the columns, indices, and foreign key references. So this is a CLI tool that we get with Postgres just built in, and an ability to explore the database and understand it. And there's others, there's many others. Second, we have scaling. Allow multiple users to query and update records at the same time, so our program can scale. So Postgres supports this well, and it also, we'll be talking about this much more today. Data validation. So Postgres can validate records and relationships. If I try to enter something into the channels table, and I put in for updated at, let's say I manually try to set that to be something that's not a timestamp without time zone, Postgres will validate that. The same goes for references. There's a constraint on the table posts that says that it's channel ID. Actually see in this table. It references the ID. Yeah, sorry, it's on the post table. The post has a column called channel ID, and that references ID on this table. So there's a post somewhere and it says, my channel is channel number 1. This constraint forces the database to maintain a channel with ID 1. That's probably sounds pretty confusing, but we'll talk about it a lot more today. Data integrity. Ensure critical updates like debiting one bank account only succeeds when crediting another also succeeds. That's something that we call a transaction, and it's a very important database concept. And it prevents unintentional changes to information. Finally, searching. This is one of the best things in SQL, I think. You can return records that match multiple complex criteria. So all of that searching you might have done on a spreadsheet through various means is like a core feature to SQL, to query and get complicated information with complicated criteria. Okay, so what was this talk about? We talked about persistence. We talked about the anti-pattern to persistence spreadsheets. We talked about relational databases and the relational database management system. This is just one solution to persistence, but it happens to be a very popular one. From here on out, we're going to be using SQL and seeing what it actually can do. Before we transition into that, questions so far?
I have one, Jake. So when we were talking about the post developer and the what was the last name? Post developer and channel, I believe.
Correct.
So the post or the developer in the channel wouldn't know about the post, but the post would have IDs that are relational to the channels and the developers. That's how they keep track of the relationship.
Yes, so if you look at this printing of the channels, I don't actually have the post table to show here, but what this under reference by at the bottom, what this constraint is saying, there's a constraint somewhere called post channels ID F key, foreign key, and that is telling us that there's a column on posts called channel ID. So the post knows, the post says that there's a channel out there that I belong to, and the post has a similar column called developer ID. The post says there's a developer out there that I belong to, and then using these constraints, we're not allowing that ID to be wrong. So the post can't have an ID. The post channel ID can't be 1, but then there's no channel with ID 1. So yes, at the database layer, the channels table columns don't say anything about posts.
Gotcha. And then the second question is, for like the examples and such, just out of curiosity, are you on Windows or a Mac for your setup?
I mostly develop on Mac.
Gotcha.
I don't know what Jack's doing these days.
Yeah, I'm on Mac as well.
Thank you, guys.
Yeah, we both came from a Ruby background. I mean, we worked together doing Ruby, I should say. I was starting out, Jack had been programming for a long time. And it used to be Ruby was really not very good on Windows. So at that time, everyone who was doing Ruby was on Mac or Linux pretty much. But I guess that's changed a lot. But you know, old habits, I guess. Are some of you all on Windows?
Yeah.
Yeah.
Microsoft, it seems like they've worked hard, and open source communities have worked really hard to make developing on Windows a lot better. I think it used to have sort of a bad reputation, but I guess it's gotten a lot better.
Yeah, and especially with the, what is it, the WSL, the Windows subsystem for Linux, you can basically run a Linux VM pretty transparently now. I've tried that a little bit and it seems pretty good.
Yeah, that's what we're using here. The only thing is, we were setting it up yesterday, and it's like you have to be a super user to do anything in WSL, like to do it properly. So whereas everybody on Mac is just like, you can just go into your terminal and type in PSQL. It's like I had to set up an alias to make the decision, like, so it knows that I'm doing a super user command and I'm also switching the user to Postgres. So it's like just an extra step that you have to do, but it's worked more or less how all the instructions have said it would after I did that.
Yeah, I mean, just an anecdote. I've worked with one dev in like 10 years who is like a committed Windows dev. It's not like to say that it isn't a viable path. I just think that the easy road, the path of like least resistance is like a Unix based system, either Mac or Linux. That doesn't, I don't want to discourage anyone from going down Windows. I just want to I think it's good to just be like, those like extra steps are kind of like historically part of the experience of being a Windows developer, unless you're developing something for Windows. If you're doing like Microsoft tools development, then it's probably absolutely the best thing.
I'm 100% saving it for a Mac. 'Cause, yeah.
Yeah, I'm a fan. Other questions? We have a little bit of time. Kind of blew through that quickly. Well, cool. There'll be a lot more to ask about. So we're gonna stop here and take a 15-minute break until I'm so messed up on time, until the top of the hour in Central Time, and use that time. If you don't have P-SQL set up or you need help, post in Slack and I'll try to help. And pull down this repo and try to get set up with a P-SQL instance, and I'll stick around on Zoom. See you in 14 minutes. I'm enjoying this conversation about operating systems and computers. It's a really good discussion. One thing I'd say about operating systems is when I got out of the army, I'd never used a Mac or Linux. I'd only ever used Windows. I think that's pretty common. I would say my suggestion there is like stay open-minded, because like try to do a little development in each of them if you can. You know, my first couple of years I did like a 6 months in Windows, and then like a year in Ubuntu, and then like a year on Mac. Not intentionally, it just kind of panned out that way. And what I learned was that for me, it was like a lot easier to try to do Ruby stuff on Mac than it was on Windows. And I kind of never went back after that, even though I'm still completely lost in the Mac like file system in general. But it's just like try each one. That's my suggestion there. Taste all the flavors. Yes, very true. If you already know Windows, like Linux is a really cheap one to experiment with, right? You can like just download a VM and try it out right now. And Mac, soon enough, some company will give you a Mac, even if you maybe don't want it, and then you'll get a chance to try that too, or borrow one. But Mac and Linux are, at least in the beginning, I think really similar. If you try one, as far as development goes, you'll get a very similar experience.
Well, it's 10 o'clock. Let's get started with SQL. So I think Jake posted in the Slack channel the repo that I think everyone should have already downloaded at this point or cloned. So let me share my screen here. Okay. We are going to start with the directory phone book. And I guess before I get started there, let me mention just a few like introductory things about SQL and the way we're going to be doing this class. We've got more material than we have time for, and that's on purpose. And along with that, we do want to, I know Jake already mentioned this, but I want to emphasize encouraging questions. There's tons of books, materials like blogs that you can read, but actually being able to ask questions and whatnot is, I don't know, like even the primary value that we offer. So, you know, if we just go through this and nobody asks any questions, you're only going to get half of what we hope you get out of it. So please do ask questions. I mean, especially things like, you know, why is it called such and such? Or, you know, why does it work that way? We may or may not be able to answer them, but some of them we will anyway. And I know when I was first learning a bunch of things, really it was just a bunch of the jargon was so confusing. And a lot of it makes more sense once you know like where the name came from. Like, for example, I don't know how many of you have maybe used the tar command, or you've had like a tar file. And it's like, why is it called tar? That seems kind of like a stupid name. Well, it goes back to tape drives. It was tape archive is what it was short for. And then knowing that background, actually you start to understand like how that command like evolved to the way it did, why it does certain things. Or like printing out a file with cat, like why cat? Why not dog or something like that? It's like, oh, well, it's concatenate. And it was originally designed to add files together, but it also can print it out. And now people just usually print stuff. So that type stuff, if you run into something like that just doesn't make sense, you know, ask why, and hopefully, you know, Jake or I might be able to explain it. Okay, to jump right into it, we are going to open this SQL workshop repo here. We're going to go into the phone book directory, and we are going to open lesson.sql. And this actually is a SQL file. Our comments are in comments. So that's the first thing as far as SQL. How do you do a comment? Well, 2 dashes. And the first thing we're going to do here is we are going to create a database. So I have the terminal in VS Code open on bottom. Do I need to make this a little bigger? I'm going to zoom in a little bit on this. Hopefully that makes it a little easier to read for everybody, but you can still see it. So the first thing we're going to do is we're going to, at the command line, we're going to run this command, create DB phone book. And it looks like I still have my previous one left there, so I'm going to delete mine first. All right. Create DB, drop DB. They're good Unix tools, as in when they do what they're supposed to, they don't say anything. They only put output when something goes wrong. So if you ran it and it looks like nothing happened, that means it probably worked. Now, the next thing we need to do is in this phone book directory. So we're going to change directory into that phone book. And from there, we are going to run this command here, this psql-f data/context.sql phone book. And what that command is going to do is we're running the psql command. That's how we're going to talk to Postgres all day today. The -f says, instead of typing in a command, I want you just to read this file and execute it. I'm going to tell it which file. And phone book tells it which database to use. Because as Jake mentioned, this is a relational database management system, as in it can actually have multiple databases all in one server. And we have to tell it which database we want to use. Well, we want to use the phone book database we just created. And mine spit out a bunch of noise here saying it did things. Yours probably will just say the insert 01. Probably won't have the timing. I have something configured on my machine to tell me how long each command took. So if you don't see that, it's not a problem. Okay, then lastly, we're going to start that psql client. So we'll run psql. We'll tell it which database we want to use. And we should see something like this here, where it says phone book and then equal and $. And Jake mentioned that term before of a REPL. This is the Postgres REPL. REPL stands for read, eval, print, loop. So the read part is we type something into it, and Postgres is going to read what we typed in. Eval says whatever we typed in that it just read, it is actually going to evaluate it, or it is going to run it. And then the print says whatever it did, it is going to print the results back to us. The loop means it's going to keep doing that. So when you hear somebody talk about a REPL, that's what they mean. And REPLs are really common in programming. We have a REPL for Postgres, you have a REPL for Python, you have a REPL for Ruby. Even your shell, just Bash or Z shell or whatever you're using, that is a REPL as well. Okay, any questions there so far? Hopefully it's working for everyone.
Yeah, what's the -F stand for? Just because, like you were saying, it's good to know
Yeah,
what it is.
-F is for file. It's going to read the file we pass it.
Just file. Gotcha. Thank you.
Mhm. Okay, so in SQL, the most common statement that we're going to use is the select statement. So let's start with this here, that select name, comma, phone from contacts. Contacts table we created by, loading that file with -F. So let's just see what happens here. We got some test data. So I saw a question in the chat about -F versus the, I guess it's the less than sign there, or the redirect operator. They can be used similarly. They're technically not exactly the same thing. The greater than and less than thing is a operator that you use at the shell. And what it does is it resets your standard in and your standard out. Now, I don't know if you've really run into that concept or not, but a command line program, in fact, I think this is universal. It's definitely in all the Unixes, and I think it's even in Windows, and I'm not even sure where it wouldn't be true. But it starts with 3 files available by default: standard in, standard out, and standard error. And what the shell does when you use the redirection operators, in the greater than or less than, is that tells it, instead of standard in reading from the keyboard, instead standard in reads from this file. So you can use it the same way as if a program has, a -F thing to read a file, but it does behave, sometimes it'll behave slightly different. Like, for example, when Postgres reads from a file, if it runs into an error on line 20, it can say I ran into an error on line 20. But if you use the redirection thing and it runs into an error, it kind of thinks you're just typing it in at, from the keyboard. So it says, I got an error, but it's not really thinking in terms of it was on line 20 of this file. Okay, so select name, comma, phone from context. So a couple things about SQL in general and the select statement. First of all, you'll notice that some places talk about, the SQL keywords are capitalized. That's a pretty ancient convention. Some people still do it. I personally do not, now that we have, color on our computer screens and syntax highlighters that'll highlight what like a keyword is and whatnot. You're welcome to capitalize the stuff if it makes you feel better. I just kind of save my, hands from any extra keystrokes than necessary. The Postgres engine itself doesn't care about casing for keywords. You can use whatever you want. Second, SQL it probably is going to look a little unfamiliar from just about any other language you've used. There's a few reasons for that. One is it basically goes back into the 70s was when it was developed. And at that time, there was a trend for, we can make this stuff easier if we make the computer languages like human languages. So a SQL thing, you can kind of read it. it tries to use like human style. It's almost a sentence. You could really just read this as a sentence. Well, select name and phone from contacts. It kind of is humanish. Industry trends, that trend kind of died out. Like the basic language was kind of the same way. And, there's a few other languages that tried that. And for whatever reason, SQL is probably the only language like that has remained popular. So if you're coming from Python or Ruby or C or JavaScript or anything like that, you're probably used to a lot more symbols and a lot less like Englishy words. The second thing that's really different about SQL is it's more of a declarative language. We are telling it what to do, but we're not so much telling it how to do it. Like in Python or JavaScript, you might actually write like a loop. In SQL, you never write a loop. You tell it what to do, and internally it'll use a loop perhaps, but it's kind of a higher level, tell it what you want and let it figure out the details. That'll probably make a little more sense later. Okay, so let's look at this first statement we ran. So it's the select command. And the very first word is just telling it what we're going to do. We're going to select something. Now, right after that comes the clause where we're saying, okay, what am I selecting? And what we're selecting is a comma-separated list of expressions. Now, what does that mean? In this case, we're just selecting columns, but a column name is an expression. But so is a number. And so is an arithmetic operation. So SQL is very big on expressions, and most places where you have a value, we're saying like this column or this like raw value, it can be anything that resolves to it, any sort of expression. Okay, so it's comma separated list of expressions. A column name is an expression. So this will evaluate to whatever is in that column. Then we say from. So typically when you're doing a select statement, we're reading from some table. So we say from what? Well, from the contacts table. So this is going to read the name column and the phone column from the contacts table. Now, sometimes we don't want to type as much. So star is a shortcut for all columns. Now, what if we don't want every single row? Well, in that case, we're going to use a where clause. So the where clause filters which rows are acceptable. So let's run this one here. And you may notice one other thing here. All of a sudden, the command is not on a single line anymore. The SQL language doesn't care about line breaks. It knows the statement is done when there's a semicolon. So like, I think you're all learning Python this cohort, right? Okay. If I recall correctly, you do not have to use semicolons at the end of a statement in Python, right? I believe that's right. Okay, cool. So SQL is more like C in that you can break it up into as many lines as you want. It doesn't care about indentation, but you have to tell it when you're done with a semicolon. So in this case, it's a little easier to read if you break it up into multiple lines. Now, these are pretty trivial small queries at this point, but sometimes you work on a couple hundred line SQL query, and you really do want it to be broken up into many lines to have a chance of understanding it. All right, so here's what this does. Here's what the where clause does. The where clause is a value. Well, the where clause, again, is an expression. In particular, it's a Boolean expression, as in it resolves the true or false. And this expression is evaluated in the context of every single row. And for every row, if it evaluates to true, it includes the row. If it evaluates to false, it rejects the row. So for example, here we had our select star and we had all the rows here. And then the next time we said where phone equals 579 such and such. So what it actually did when we ran this query with the where clause is it looked at this first row and it said phone equals 579. And it looks at this and it says, oh, that's false. It does not equal. So false, it rejects this row. Then it goes to the next row. It says, is this true? No, that's false. And it keeps going all the way down until it runs into this row. And in this row, it evaluates to true. So it says, okay, I do want to include this row. And it goes on to the next row and it rejects this row and it rejects all the rest of the rows. And ultimately we get down here. So we ran this query and all the rows except this one row were rejected. And they were rejected because of that where clause evaluating to false. So does that make sense there a little bit? Hopefully. Cool. Okay, let's try a little exercise here. I'll give you about 2 minutes to try this. Should just be able to adapt that SQL query we already have. And just FYI, for all the exercises, there is a solutions.sql in the same folder as the lesson.sql. So whether you get stuck and want to look at it now, or if you want to review this stuff after the fact, we do have the solutions for all the exercises. I'll give you about a minute or two here, and then we'll talk about the solution.
If there are more than one solutions in the table, does it stop after the first one, or does it continue to go through every single one to find them all?
It tries to find them all. So there's another command, or there's another thing called limit, where we can say just find one of them. But otherwise, it really is find all rows where this condition is true.
Jack, is there a difference for putting the modulo symbol in front of a search term versus at the end of it?
The
modulo, or like the percentage symbol, I mean?
Oh, okay. Yeah, yes. So what that's going to be, that's a wildcard symbol. So it's kind of like the equivalent of using star at the shell or dot star in a regular expression.
Also, Jack, is there any reason why when we're searching or we're selecting more than one column, that one term is, you know, like highlighted or in a certain color, and then the one after the comma is not?
Oh, you mean the syntax highlighting here?
Yes.
There is a reason, but the reason is the syntax highlighter is a little confused. In particular, it's just looking for keywords, and name actually is a SQL keyword in some contexts. So it's highlighting it. Yeah, that's kind of a little confusing there. But yeah, it's just because it happens to be you know, a keyword in a different context, and the syntax highlighter isn't smart enough there.
it's trying to make SQL keywords that like magenta color, right? So you like can learn what are the SQL keywords.
Yeah, exactly. Yeah, and that's one thing we talked about, like SQL is kind of English-like. There's like a couple hundred keywords or something ridiculous like that. Most of them can be used as column names, and the SQL parser, Postgres is actually smart enough to figure it out. But the syntax highlighter here, isn't. And for that matter, this is just kind of like a generic SQL syntax highlighter, and every database engine kind of has their own dialect of SQL. The common stuff is the same, and if you can write or read any of them, you can read any of the other ones. But when you write it, there might be like minor differences occasionally. Pretty much everything we're doing should work just about everywhere, I think, since we're staying on the more or less on the simple path. But when you get more advanced, features diverge a little bit.
And don't use double quotes, right? Because I know that was giving me errors last night. Only single quotes.
Yeah, so single quotes and double quotes mean different things in SQL. So a single quote means I am quoting a value. A double quote means I am quoting an identifier. So like, for example, we could do this, and this will still work because we're just quoting the name. We're quoting an identifier rather. Name is a little ambiguous there. And we could do, all of these actually, and it would work. But most of the time the quotes are superfluous. But that does technically allow you to like have column names that have spaces in them, for example, or table names that have spaces. Now, don't do that, but you can. All right, so here's the solution for that. Find the phone number for Lori Abshire.
Bro, Jack, before you move, are you able to see the raised hands in the video chats at all? I've seen a few folks raise their hand.
Oh, okay, I see one there. I can't actually I don't have enough room for like all of the pictures on one screen. I don't know, does it move them to the top when a hand raises or?
Yeah.
Oh, I did not realize that. Okay, I'll try.
If you want, they can just like interrupt you, like if you're okay with that. That way you don't have to have it on the screen.
Yeah, go ahead. If you have a question, just speak up. Like I said, I mean, learning a select statement, there's 1,000 blog posts, 100 books, hundreds of videos that'll teach you how to do basic select stuff. It's a lot more important that you get your questions answered than that we get through some arbitrary amount of curriculum that you could just read on your own time. So yes, we definitely really want questions.
Hi, Jake. Just a quick question.
Mhm.
So is it best practice when you encounter with the reserved keyword to add a quotation mark or just leave it as the way that it is?
I generally leave it the way it is unless there is some ambiguity, or unless the database will whine about the ambiguity. And usually, like in the select clause, I believe they actually refactored the parser recently. So there's only like 20 words or something like that that you absolutely cannot use. Like I'm guessing you probably couldn't actually use the word select as a column name without it whining about it. But what I find is I just really don't like having to do that because then I have to remember that everywhere. So generally, if I have a name that's going to be a problem, I just find a different name for the column or table.
Thank you.
Mm-hmm.
I think I saw, was there another hand? Another question?
Yeah, I just had a quick question, Jack. So on lines 19, 20, 21, you have them all separated by an enter. Is that like best practice? Because I was looking on Stack Overflow yesterday about SQL questions and everyone always writes it like separated like that.
There's no one standard for how you should do it, but this is pretty common. It really is just a matter of like, what do you find easier to read? So like the convention that just I personally lean to is like every major clause goes on a new name or on a new line. So like select from where. So those are basically always going to be on new lines. Then if we have something where there's multiple conditions, like we're eventually going to get to, we're joining some other table or something like that. And for kind of like subparts of a clause, generally I'll also use a new line for that and indent it a little bit. But unfortunately, there isn't like one single, like this is the way it should be. Wherever you work, they may have, some particular standard, or, you'll probably develop your own after you use it quite a while. And sometimes just for something really short, like there wouldn't be anything wrong with doing this, because this is short enough. But this is a very short query, and oftentimes you'll run into, much bigger ones.
Jack, I picked up that your style of writing that way. I picked that up working from you. I think SQL just feels like Yoda language to me. Like it's not how I think at all. So breaking it up into lines like Jack has done there, I think helps me. We'll talk about this a little bit, but I like kind of read it backwards. I'm like, from contacts, where this thing, select the name. So breaking it up into new lines like that helps me a lot.
Right. Yeah, that's another one of the oddities of SQL, where they kind of like trying to make it English-like. It kind of maybe backfired a little bit, because really, if you think about how the system actually works, it really starts with from, and then it goes to where, and then select happens last. So when you're trying to build a mental model of how this works, the order stuff happens in the SQL code is not the order it actually gets executed. So our second exercise here is pretty much the same. We select a name, select it from the particular table, where the phone number equals this thing here. And we can do like a reverse lookup here. Now, we mentioned that the where clause is a Boolean expression. If it's true, we get the row. If it's not true, we don't get the row. Well, there's a lot of operators we can use that'll give us back a Boolean expression. So one of those is the like operator. So we're going to use the word like instead of an equal sign. And we're going to run this. And like is a pattern. Instead of saying it exactly matches the string on the right, we're saying match the pattern of the string on the right. And in that pattern, the % sign is a wildcard. It says match any number of any character. So in this case, it made it easy for us to find somebody just by their first name, and we don't know what their last name is. And just like a star at the shell or a dot star in the regular expression, the position of the % does matter. Like if we were to put that at the beginning, there wouldn't be any matches, because that would be saying find anything that ends with Tammy and then nothing else. And we have the example of it here. We'll just do this one together here. So for the phone number for the last name of Herman, since it's the last name, we're saying I want any sort of first name. So any number of any characters followed by Herman. Now, like is case sensitive. So like if we were just to change this, no matches. I like for insensitive like is a case insensitive pattern match. Okay, so that's our very basics of selects. We're going to come back to select and we're going to do a lot more there, but it's not just useful to be able to read from a database. We also need to be able to insert rows into it. So before we start with insert, was there any questions about the basic select statement? All right.
I have
Very
a
well.
quick question. When it comes to searching, can you do like two statements with the like, for instance, you're looking for a particular string of letters within the entire thing. It could be in the front, it could be in the back, but you don't know.
Yeah, so there's a couple things you're asking there, I think, and we can talk about all of them. So yes, if we put multiple wildcard matches, this will match either one. And we could do something like, okay, let's find anything that has an H in it. So yes, we can put multiple wildcard matches. The other thing we can do is we can put in multiple conditions, multiple Boolean conditions joined by the word and the word or, for Boolean logic here. So if we said, okay, the name has to have an H in it, and it has to be in the 919 area code, we could say something like this and have multiple conditions joined by and.
Is the tilde operator in Postgres like functionally equivalent to the like keyword? Because I was using that to achieve something like this in one of our challenges last night.
It's close. So let's just take a quick gander at that. So if we did use this, let's see it. Yeah. We would end up doing something like that. So the tilde is a regular expression match. So we could do like, if we wanted to look for the first name of, we'll say Lori again, we could do something like this. So yeah, if you know regular expressions, Postgres does have a regex engine, so that might be a more convenient way. Like is more limited. It's a much simpler pattern matching, which also means it often will be a little bit faster. So if you can only use like is probably more performant. But yeah, they're very similar in that they're pattern matching, but they use a different pattern language. With like, your only special characters are % and I think it's underscore is to match any single character. Whereas with regular expressions, you have all sorts of stuff with backslashes and carets and dollar signs and dots and stars and all that sort of stuff.
Got it. Thank you.
Mm-hmm. Okay, on to insert. So the insert statement is how we, insert rows. So the syntax is it always starts with the words insert into. Next, we tell it what table do we want to insert into. So in this case, we want to insert into the context table. Next comes a list of comma-separated comma-separated identifiers in a set of parentheses. And those identifiers are the columns that we're going to insert into. Sometimes you'll see this entire thing omitted. That means we're going to insert a value into every single column. But usually it'll be specified, and it's best practice to specify what columns you're going to insert into. Otherwise, if somebody adds a new column to a table, your SQL will basically be guaranteed to break. So we say I'm going to insert into the context table. I'm going to provide values for the name column and for the phone name column and phone column. And then this part here, values, this is 99% of the time when you see the values keyword, it's going to be connected to the insert statement. But technically, the insert statement takes basically a table value or a result set, and it puts that into the table. So technically, this won't be on the test, so to speak, but technically we can just run a values statement directly. And it kind of works like a select, but 99% of the time you see this as part of an insert. So values says I'm going to have a list of rows here. Inside of each row is going to be delimited by a parentheses. We're going to have values inside it. So let's run this. All right, so it tells us what it did here. This insert 0, 1. So every time you run a statement, SQL is going to give you back a message that says what it did. Now for a select statement, the psql tool doesn't say the select thing back at you. It doesn't print it out because it's kind of, obvious, I guess. But for any other statement, it'll tell you what it did. So the first part is the word, that says this is the command I did. So it inserted a row. The next digit where it says 0 is literally meaningless. And then the next value, the 1, is it says, how many rows did I insert? So we can insert multiple rows at once. We'll probably do something like that later, but yeah, tells us how many rows we inserted. Now you might be wondering about when I kind of glossed over like, hey, there's something here that literally is meaningless. And probably, at least I'm guessing somebody at least is probably saying, why? That seems kind of stupid, right? Well, the why is because of backwards compatibility. It used to mean something, but what it meant is no longer relevant. But to avoid breaking any tools that were relying on looking at this result indicator and interpreting it, they just said, okay, rather than changing this and breaking all the programs, we're just always going to return a 0. So that decision, that change was made, I don't know, 10 plus years ago, but because of backwards compatibility, it's just always going to be a 0 there. Okay, we inserted a row. Let's try inserting a row without a phone number. Let's see what happens here. Whoa, okay, it did not like that at all. If you run this, you should get a similar error message, probably not as many details. There's some options with psql where you can say, like, give me every single detail about what went wrong. And I have that turned on, but it's off by default because, you probably don't really care where in the C code this error actually bubbled up from. Whereas this tells us stuff down to that crazy detail. But I like seeing all that extra stuff, so I have that turned on. But what you probably see when you run this, you'd see the top 2 rows. And we can talk about, when we take a little bit of a break, we'll talk some about the all those settings with psql that give us all these extra things like timing and, colors and all that sort of fun stuff. But just for this error here. So like Jake said, one of the most important things is actually just to read the error message and it'll tell you what went wrong. So null value in column phone of relation contacts violates not null constraint. And detail failing row contains John Locke and null. Okay, so it is pretty straightforward. It tells us what went wrong here. One thing that might be a little confusing is this, what is a relation? Well, there's like math stuff that, mathematics people use some of these terms, and it's a lot of relational database stuff came from that. In fact, relational database, it's not just that the tables are related to each other. There is some like mathematical terminology underneath all that. And oftentimes the word relation will be used 90% of the time it means table. Some of the times it means a view or something that is acting like a table but isn't the table. So again, without getting into a lot of unnecessary detail there, most of the time if you see something about a relation, it means table. All right, so here's a new command. This looks kind of different, huh? \d context. So pschool, the Postgres REPL, has what it calls meta commands. This is where instead of sending this text to the SQL server and having the server evaluate it, this is telling the actual command line tool to do something. And basically all of those commands, I'm trying to think, there might be an exception or two, but practically speaking, all of those commands start with a \. And there's a lot of them. If you do \, it brings up help and tells you, like I said, there's a lot of them here. You can kind of scroll through, pages and pages of different things it can do. We're not going to worry about most of those. Though for that matter, that error verbose here, that command, I have that turned on by default. That's why I see more errors, more error detail. But \d is probably the most common one you'll use. And if you give it a name, you can think of D for like describe. It'll tell you about that table or that view or whatever it is you told it to describe. So in this case, it prints out the message and says, okay, what do I know about the table context? Well, you might also wonder here, what is this public dot context? So Postgres has the idea of what it calls schemas. And if you think of it in a file system idea, it has the idea of a directory that your tables live in. Now, by default, everything lives in the public schema, and all your commands look in the public schema by default. So unless you're specifically like opting into it where you want to use schemas, you generally don't have to worry about it. You can just pretend they don't exist. But you will see things like this occasionally where it's printing out the name of something and it prints out the full name, which includes the schema. So that's why it says public there. All right, so then it tells us, all about that table. Okay, first part, column, and it tells us what the name of the column is. That's pretty simple. Next thing it tells us is the type. And remember we talked about, that SQL can be verbose and kind of English character varying. Okay, so that basically just means it's a string that can be any size. So you'll often see that written, there's a shorter version of varchar, V-A-R-C-H-A-R. And there's also the text type, which in Postgres, the underlying implementation is the same. So 9 times out of 10, I just always use the text type now just because it's typing a little less. But Postgres will give us the long name here in the type. And the type, I guess to talk a little bit more about types is types constrain what, type of value can fit there. So like this says we can have text, but we could also have like a date, or we could have a type that's an integer, and that would restrict it to, okay, we're only going to have integers here. We're only going to have dates here. We're only going to have timestamps. Next, this column that's blank is collation. So if you think about what it means to collate something, it means, to set it in order. So this is another one that 9 times out of 10 or 99 times out of 100, maybe, most of the time you can ignore. But what this is useful for is when you're storing data in a language that has a different rule for ordering. Like, for example, some European languages, they may still use the Latin alphabet, or our typical 26-character alphabet, but they may have, I'm trying to think, I think it's German has like a couple like letter couplets that when they're together, they act as a single character that has like a different order in the alphabet. There's different languages that have different orders like that. So collation is how you tell Postgres, when you sort this, use this particular criteria for sorting. Again, it defaults to, at least for any of our installs here, it's going to default to US English. So you won't really have to worry about it now, but that's what it is. You may see it occasionally. Not or nullable. We're saying these things are not null. And one of the meanings of null is empty. We're going to talk more about null later. Null is kind of interesting. We'll have some fun with that in a bit. But one of its meanings is empty. So for now, we're just going to say null means empty. And the columns in this table are constrained to be not null. So we're just saying it must be present. Lastly, over here, default, you can give it a default expression to, when you insert a row, if you don't provide a value, you can provide a default value. And we have not done that for either of these tables.
Quick question, Jack. For character varying, is there a logic inside of SQL that, let's say if I put in the word true, it'll save it as a Boolean instead of like a string for the word true or something that's like that?
So if you give it the word true as in the Boolean value and you try and use that as a varchar or text, I believe that'll actually work most of the time. Yeah, it works because Postgres will automatically convert types when it can. But they are technically different. And if you're using like a prepared statement in a database driver or something, it may be more strict in certain contexts, but most of the time it'll convert between types if it can figure out how.
Thank you.
Okay, let's try an update statement here. So update is how we update a row. And it's kind of similar to the insert statement in that we tell it, what is the command? The command is update. What table do we want to update? Context. Then we tell it, what columns do we want to change? So we want to set the phone column to this expression on the right. And we're setting it to just a literal value here, but it could be an expression. Like if we had a timestamp thing, we could say set it to the current time, for example. And which rows do we want to change? We want to change all the rows where name equals Simone Bear. So we can run this. And this result that we get back tells us, hey, I updated a single row. And that can be really useful because, like, for example, maybe you thought you updated something, but it actually didn't do anything. Postgres considers it entirely successful to say, hey, you told me to do something to all rows that match this condition. And success, I did it. Now, there weren't any rows that matched that condition, but it did it to all 0 of them. Success. So that is something to just watch to know like what number here. Or worse yet, if you run a command and you want to update one row and you see it come back and says update 9,872, hopefully you're on a development machine, because otherwise that's beginning of bad day. All right, let's see here. So of our major 4 things of, creating rows, retrieving rows, updating rows, and deleting rows, our only one left is to delete a row. So let's try just deleting this row here. And you probably start to notice this pattern of command, then what table are we going to do something to, then what rows are we going to do it. And again, same thing comes back. It tells us I deleted something. How many rows did I delete? 1. And just like update, if we delete something and there were no rows, Postgres considers that success. You know, it deleted all 0 rows. Now, this is kind of a big deal. They all allow a where clause, and you really want to be sure that your where clause is on an update or a delete statement, because if you don't, it'll happily do that to the entire table. And again, if you're if you're on a database that matters, that can definitely be start of bad day. Okay, with that intro, it looks like, yeah, it's 10:52 now. Let's take an 8-minute break. We'll start again at 11.
Raphael or Ankur, whoever's here, could you open the breakout rooms real quick? I want to see if you can help a student real quick with the setup.
Yep, you got it.
Andrew Tran, can you join me so we can help him? Or if anyone.
I could hop in. Who we helping?
Sanjaya.
Let's go to 1.
There was a comment in chat that I think brings up a good point for those who are around. Right, like typing delete into a command line is scary, and you're typing it really slowly because you don't want to get it wrong. And the comment was from Lyman. Can I just get a preview first? Two thoughts on that. One is, yes, you can get a preview, which is you can do commands in something called a transaction, which we might get into a little later, where you say begin and then you type whatever you want, and then when you're done you say roll back, and all the things that you did didn't happen. So you could presumably see the impact of a command. But the other bigger point, I think, is that in the real world, what this is I think a great way to learn SQL. In the practical world, you're not going to be typing delete commands into any database like of consequence. Like you're never going to be typing. You're never going to be connected to like the production or even staging database and like entering SQL commands that delete records, unless you're really lost and things are going really, really bad. There's a whole bunch of safe ways to do what we're doing that make it all very low risk, which we can talk more in detail about that. So I think it's cool to like do this stuff on a local database and just blow away records and see what happens, but it isn't like part of the job of being a programmer. Isn't like doing like surgery on the production database where like one wrong keystroke's gonna nuke the business.
Yeah, I totally agree. Kind of the way I look at it is, if you have to do this on the production database, you're already having a bad day. And if you're not real careful, it's going to get a lot worse.
Right. We never quite get into this because we always sort of run out of time, but I'll just like give a short description. The way you change data on a production database, if you're changing tables, you write these scripts that are called migrations. Those are changing usually the construction of a table, and you write them in development and you run them against your local database, and then you roll them back, and then you deploy them to staging or QA, which is like an almost identical database to production, and you do the same thing, and you run it forward and you run it back, and you verify that everything's fine. And then after all that's done, then you do it on production in an automated way. You're not even like manually running these commands, they just happen automatically. And if you want to change data, if you want to delete stuff, a lot of databases just don't delete anything. They do something called a soft delete, where the record says I am deleted, but it's not actually deleted, which has its own set of problems, but it's a way of safely deleting things. And then or you'll deploy a script to that environment that does the delete, and you test that script out on each environment. So if you're doing things the right way, carefully and methodically, then you're not like ever doing this on a production database this way.
Yep. Yeah, if you're at a big company, you won't even have the ability to. And if you're at a small company, you hopefully will be there. Use great discretion.
Yep. I think a good habit to get into is like always just being like, where am I and what are the stakes, right? I'm in a development database on my computer that came from a SQL file. I can just blow this away over and over and over again. There's no consequence. Jack actually had a nice thing on his old environment. Well, it says local right there on in his terminal, so you know we're on his computer. But Jack used to have a thing where if you like SSH'd into different servers, like the terminal would turn red. It would say like production.
Yeah, yeah, I still do that actually. You can configure iTerm, which is the terminal client I use to look at your command prompt to see what your host is, and then based on that to like switch profiles. So yeah, I have stuff where my terminal turns red if I'm on production to try and remind me don't do something stupid. And even that's one of those things that, you know, you shouldn't really have to SSH into production servers very often. But anywho, I think we're about back here. So let's go back to select and let's talk about order by. So order by is how we sort things. So I'm just going to copy this here. We're going to order by name. By default, it is ascending order, and alphabetically, you know, internally, these are just numbers, and B is a bigger number than A. So it goes from small numbers to big numbers. And we can reverse that by saying DESC for descending instead of ascending. And we get stuff in the other order. Just like the, you'll probably get tired of hearing me say this is an expression. Just like other places, this is also an expression. So if we were to do something like call the length function on the name column and sort by that, well, now we sorted by shortest name to longest name. Excuse me. And it also is a comma separated list of criteria. So if we wanted to alphabetize within each length of name, we could do both at the same time. Now, obviously, this is kind of a contrived scenario, but frequently you do want to sort by multiple criteria.
Hi, Jack. I had a question about delete from earlier.
Sure.
So when I put into delete from context where name equals Kylene, and then I try to use the wildcard operator, it won't delete it, but it'll delete it if I put her full name. Like, why is that?
So with the wildcard operator, are you still using equal?
Yeah, I have it where name is equal to Kylene, and then at the end of Kylene, I have like the parentheses thing.
Right.
But then it does delete 0.
Right. Yeah. So the what's going on there is equal does not do the pattern matching. So you'd need to use like.
Ah, awesome. Thank you.
Mm-hmm.
Can you
go ahead, Jesse.
can you use regex with the order by name as well? Regular expressions.
Right. So yes, but I'm not sure what that would mean exactly. So
Like let's say I wanted to order by the last name instead of the first name.
Okay. So you would want to use a regex that extracts the last word and then order by that. Yes, you could. Oh, let's see if I can do this off the top of my head. I'm not sure if I can actually. But this is a good example of just like how to think through these type problems. So the first thing that I would do is, instead of doing this directly in the order by, I would do it in the select clause so I can see what's coming out. So there's a command called substring. Let's see, what is this? Oh, I don't remember the syntax right offhand here. Let's see if maybe Postgres can help us here. Remember, we have our / commands. But we can also do / help and a particular command. No command for substring, huh? That's too bad. So this is actually a good chance then. Well, let's actually just dive into this a little bit. This is kind of going to be a fun problem. So the Postgres documentation is really, really good. So I'm just going to search for Postgres substring. I guess that's a little bit of an advantage. I happen to know that that's the name of at least one of the functions that can do this. So I'm going to Google Postgres substring. And I'm sure these tutorials are probably okay, but the Postgres docs themselves are really, really, really good. So I usually just go straight to the Postgres docs. Now, one weird thing here is, for whatever reason, Google tends to really like finding like ancient versions of the documentation. So this is an unsupported version of Postgres, like 9.1 is ancient, the current one is 14. So I almost always have to go here and click current just to get whatever the current docs are. So let's see here. There are a ton of these things. And I think I see somebody in the chat saying split part. That might be even better. Let's try doing this a few ways, actually. So yeah, let's try the split part first. So, okay, so in the documentation, we look for a string, we look for a delimiter, and then we return the nth field. So yeah, let's try that. So if we wanted to sort by last name, actually I said, yeah, let's try. Okay, it looks like that does do what we want it to do. So if we were to move that split part into the order by clause, we can do that entire expression. There we go, sorted by last name. If we actually, this is probably, split part is going to be the superior solution here, or well, it's probably the best solution when we know we just have two words and we're trying to split them. But with the original question about actually, can we use a regex to do that? So, oh, I guess it's substir, same as substring. Okay. So we're going to use this substir thing. Let's see, we get a string. Oh, let's see here. All right, maybe that's not the one that can let us use a regex. Oh, returns captured substring, replace. Oh, let's see here. Okay. Oh, I know there's a way to do this, but it's escaping me at the moment. Oh, it is substring, and it's string from pattern. There's substring is actually overloaded, where there's a few different variants of it. Okay, so string text from pattern. Okay. Yeah. All right, let's just try that. So yeah, if we see from pattern, I think was what it said. So the pattern for a regex here would be something like word plus to end of string, I think. Yeah, okay. So if we wanted to do it as a regex, that would be how we would use a regex to extract the last name to sort by last name. So that was kind of fun. I like doing that type of stuff, especially when I do manage to figure it out. All righty. So any more questions on that type of stuff with like order and all that? Okay. Well, next keyword is limit. So we can say, you know, how many of these do I want to get back? And it'll limit to that many. Now, usually you're going to want to include an order by clause as well, because otherwise, like if we just say select name from contacts limit 1, well, how do we know which one we're going to get? It so happens, for whatever reason, we're getting Miranda Carroll now. But there's no guarantee of that. Like just for kicks here, I'm just going to update contacts. Oh, set name equals name. So this actually won't, in theory, this won't make a change, right? I'm going to say where name equals Miranda Carroll. Okay, so I updated a row, but you know, we updated it to the same thing, right? So let's just try this limit 1. Huh, now we're getting somebody else. That's kind of weird, huh? So the reason for this is in SQL, if you do not specify an order by clause, the rows will be returned in an undefined order. So if you care about order, you always have to specify it, is what that boils down to. The actual reasoning for like what order they actually come back into, you know, it can vary from like what order is this thing literally on the disk to, you know, maybe Postgres actually, if you have 2 people doing the same query at the same time, you know, it'll actually like reuse stuff. So it might be you jumped in halfway through somebody else's query and it says, oh, I'll just grab some of his. So, you know, regardless of the exact underlying reasoning, you need an order by if you care about order. That's what it boils down to. Okay, now we're going to start getting into a little more nitty-gritty stuff. How do we tell rows apart? You know, we've got a phone book here. We have names and phone numbers. Well, there's definitely a lot of people that have the same name. And it might be a little less common nowadays when everybody has a cell phone, but people do share phone numbers as well. I mean, especially you go back when people actually had a, you know, a house phone, you call somebody, you know, there might be 5 people that all share the same phone number. So we have overlapping names, we have overlapping phone numbers. How do we tell rows apart? So in database terminology, a unique identifier is called a key. You know, Jake mentioned, you know, primary keys and foreign keys, mentioned those kind of in passing in his presentation this morning, but we didn't dive into what they actually mean. So we're going to go a little deeper into that right now. So a unique identifier is a key. And the most important unique identifier is called the primary key. Go figure, primary, most important. And with few exceptions, every table should have a primary key. Just as an aside, we mentioned that term of a foreign key. Foreign refers to it being on a different table. So when table A has a column that is an ID or a key on table B, which that'll make more sense when you see it. But all right, let's try this, running this arcane command here. So I'll explain what this all means, but this is something that I definitely don't expect anybody to remember, at least not until you use it a lot. It's worthwhile memorizing, you know, select, update, delete, insert. And even that though, as far as memorizing, just use it and you'll just start remembering it. It's not something you need like flashcards for or something like that. But especially these things where we're altering a table and we're, you know, adding all this stuff here. The Postgres docs are really good. And for a long time, you know, whenever I needed to do something like this, I just looked it up every time I knew. And eventually, you know, after doing it for many years, start to remember a few of the things. But I would not worry about memorizing or even getting too into what every exact thing means, because you'll need to look it up every time you use it for a few months or a few years anyway. But we can go over what this means. So main command, alter table. We're going to alter a table. In particular, we're going to alter the structure of the table. We're not altering the rows, we're altering the table structure. And we tell it, well, which table am I going to alter? Then you give it a list of things that you're going to do to it. Well, the first thing we're going to do is we're going to add a column. When we add a column, we have to tell it a few things about that column. The first one is, what is the name of the column? So we're going to call the name of this column ID. The next thing is we have to tell it what is the type of the column. And this is going to be int, which is short for integer. You can type out integer if you want. I generally prefer not typing any more than necessary. Now, this little number here is one that mostly you can kind of just consider one of those incantations you just kind of have to remember or look up, rather than really diving into all what this means. But basically, this means it's going to auto increment the number. So the first one's going to be 1, the next one's going to be 2, the next one's going to be 3. If you look at Postgres, older Postgres docs, like, oh boy, I don't remember when they added this, maybe version 10 or 11, or tutorials from around then or before, you'll also see stuff where you'll see something like that, serial or big serial. That is still supported. That is the only way you used to be able to do it in Postgres, was to use a sequence which a serial creates. But this generated by something as something, that is the SQL standard syntax. So now that it's supported in Postgres, that syntax is somewhat preferred. And there's also some nasty little edge cases to do with, like, if you duplicate a table. And this new style does not have those edge cases. So if you see serial, it's just the old way of doing stuff. It works fine. But this is kind of the preferred way to do it now. And you can basically, like I said, just look at this whole phrase as saying, this is auto increment the number. And that's basically what it boils down to. Next command here, add primary key. So we are saying we want to add a primary key to this context table. Inside this parentheses, we give it a list of columns that are going to make up this primary key. Now, most of the time, there'll only be a single column there, especially if you're using Django or Rails or something, some ORM that is rather opinionated on using single column primary keys. But the database supports using as many columns as you want, really, in a primary key. And there are reasons for both ways, which don't really apply here, but that's why we have to put in parentheses, because it could be more than one. All right, so when we ran this, it added that primary key. Okay, now that we have context that we can tell apart, if this is a phone book, especially like the type phone book you have on your phone, we might want to keep track of the calls we make. So we're going to create a table here, and well, this is another one that when you create a table, first of all, if you're using Rails, you may be using their migration stuff, which is kind of their own language that you write instead of the create tables. I was never really a fan of having to learn 2 languages instead of 1, but depending on where you work, you may end up using something like the Rails language, or I'm not sure if Django has the same concept in it or not, but you may or may not be writing these statements by hand, but it's still good to know what they mean. Again, create table, it's the command. Calls, we tell it what is the name of the table. Then we provide a list of columns. And the column list, the first thing is the name of the column. Second thing is the type of the column. And then after it is any modifiers. So like in this case, ID is the name, integer is the type. Primary key, we're saying, hey, just as a shorthand, make this primary key right now, right here, so I don't have to do this later. And then generated by default as identity gives us that default auto increment behavior. These next ones here, contact ID, type of integer. And in case you're wondering, there really is no reason why this is int and this is integer. We could use either one, either way. This just gives you 2 examples, 2 different ways of typing it out if you want to save yourself some keystrokes or be a little more explicit here. Not null, that's how we tell it that, must not be empty thing. So we've got a couple interesting types here. We have timestamp TZ and we have interval. So timestamp TZ stands for timestamp with time zone. And interval is a time interval, as in, minutes, hours, days, whatever, that type of thing. Okay, so times are really, really fun. So let's talk about time a little bit. So when we say a time, like, what do we even mean by that? Like when I look at the top right of my screen, it says it's 11:24 a.m. Like, so what does that mean? Does anybody in a different time zone? Do you see maybe a different time on your screen? Yeah. Okay, so like if I say it's now 11:25, what does that mean really? And if I don't provide the date, maybe that doesn't mean something else either. So for our sake here, when we say what is a time, we are going to refer to an instant in time. Some, identifier of a particular moment in time. Okay, so 11:25 a.m. is what I see. But does a time include a time zone? Well, some of you all are probably seeing 12:25. Some of you are probably seeing 10:25. I don't know if we have anybody all the way out on the West Coast that might be seeing even like 9:25 or not. But when we say what time is it, to really identify a particular moment in time, we potentially really need a time zone. So either we need to include the time zone with every, time, or maybe we need to just say we're all going to use the same time zone or something like that. All right, how about dates? Does a date need a time zone, or does a date have a time zone in it? Well, it does implicitly. If you say, today it's March 8th, but I seem to have heard of something called like an international date line, or if you cross that, it's going to be a different date. And even just time zone by time zone, the calendar will be different, as it passes midnight. So, even things like if I'm just going to store, something like somebody has a subscription and it ends on such and such date. Well, that implicitly, that implies a time zone for when, when does midnight occur? When does that day end? When does that day start? but it gets even more fun. So can time go backwards?
No,
No? Well, again, it depends. I mean, right about 6 months ago, there's a wonderful weekend of the year that happens every fall, where we get an extra hour of sleep because the clock goes backwards by an hour. So when we say, does time go backwards? I mean, it's a trick question. You can say it either way. Obviously, true time doesn't go backwards. But does the time as told by our clocks go backwards? Yes. Our computers, you know, we have to measure it somehow. Now, what about, you know, this next question? Do all dates and times exist? Well, that's another interesting one to think about. What's going to happen this Saturday night, Sunday morning? We lose an hour. Spring forward. So as far as the clock is concerned, there will be an hour that does not exist. So that's really fun. That's only the start of this stuff, though. It gets even worse. So if you were to go back several hundred years and you were to say, you know, okay, January 13th, 1327. I don't know if that anything actually happened that day, but there's the idea of the calendar systems, you know, like the Gregorian calendar. And at various times in Europe, various countries, depending on whether they were following the Pope or they were Protestants, they decided at different times when to switch to the fixed calendar system. So in one country, you'll find 2 weeks that just don't exist. You go to another country and it'll be, you know, March 1st to March 15th don't exist. But then another country did it 100 years later, and now they have 16 days that don't exist, and they're a different 16 days. So when you go to historical dates, it gets to be a real nightmare. And there are just not just an hour here and there, there's like entire weeks that just like don't exist. It's like a real mess. Now, hopefully we won't usually have to deal with that. I mean, unless you're dealing with a database of historical events, that stuff is mostly far enough in the past, it doesn't matter. I think the odd country here or there didn't switch calendars till the 1800s or even the early 1900s, but the major countries did, you know, hundreds of years earlier. We do have things with, there are leap seconds. There are different operating systems handle that stuff differently. Like, does time actually go back for a second? Or does it do like clock smearing where it just kind of stretches out the leaps? And I mean, it is the short answer, the short of all of this, like 5 minutes we spent here, is just to say time and date handling is really, 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 really messy. And you want to avoid it as much as possible. I mean, like, here's one other one. So how long is a month in hours? Like, who knows? Which month? What day are you starting from? How long is a day? You know, I actually got bit by this early in my career. I was doing something, it was actually like a time clock type thing. And I made the terrible assumption that a day was 24 hours. Well, occasionally they're 23 hours. And occasionally they're 25 hours. It's terrible. So basically, you want to deal as little with this as possible. Basically, every language will have date and time libraries, and you want to use them. You never want to do any sort of date and time arithmetic or calculations on your own because there's just too many exceptions. So in Postgres, so all that to say, that's why we're using this timestamp TZ, timestamp with time zone. And that's why we're using interval. So like we could store, how long this took. Hopefully nobody's on the phone for a month, but it can actually store the concept of a week or a day or a month or seconds or whatever. So for one last terrible bit of confusion, timestamp with time zone. I expect that every person here would have a reasonable assumption that timestamp with time zone, has a time zone. But all of us reasonable people would be wrong. Timestamp with time zone does not have a time zone. What timestamp with time zone does is it auto converts to UTC. And it auto converts when you store something, and it auto unconverts when you read it back. So most of the time that's actually good enough. It's what we want. But that is just something to keep in mind if you're doing something where you really needed not just to know the exact instant, but you needed to know the timestamp that instant occurred in for whatever reason. It's fairly rare, unless maybe if you're doing actually a calendaring app, you might need to care about that type of stuff. But anyway, so all that to say, it's a mess. And your rule of thumb is use timestamp TZ. But TZ doesn't actually mean it has a time zone. It would better be said timestamp UTC would be a better way of putting it. Okay, after that big long digression for how times are terrible, let's just insert a couple records here. So we've already learned how to insert things. The only new stuff here is just what is the format that is used for timestamps and intervals, which is basically English, or it can be for intervals. And it's kind of the standard format, year, month, day, hour, minute, second for timestamps. And let's just insert another one here. The new thing here is returning ID. This is the new thing. So sometimes it is useful when we insert a record to know something about the record that was inserted. In this case, we are auto-assigning an ID. It might be nice if we knew what the ID was of that new record. So the returning clause lets us put in again, a list of expressions to return for each row. So in this case, we only care about the ID. We could do returning star. We could do returning, any number of the columns. And we see how that comes back here, where it basically kind of turns it into a select statement where whatever was returned, it kind of looks like a select. Okay, we can also insert multiple rows at once. And this is where I was saying that, values, you can do multiple rows at a time. And we're going to run this. And what we get back out is 2 rows from our returning ID because we inserted 2 rows. Now, what would happen if we inserted a call record for a bad contact? Wow, it works great. That's unfortunate because we've essentially inserted an orphan row here. We have a call for a contact that doesn't exist. We don't know what that means. It'd be much better if somehow the database could help us. So first of all, we're going to delete that record. So delete from calls where ID equals, in my case, it was 5 here. So I'm going to get that bad record out of the way. But now we're going to talk about those foreign key constraints. So here's another one where it's kind of just an arcane block of syntax, which again, you'll look up when you need it. What we're saying here is, again, alter table calls, add a foreign key. Now we tell it which columns are on our table. So on our table, the column we care about is contact ID. That is going to reference the contacts table, and the column that we're referencing inside the contacts table is ID. And again, both of those could have been multi-columns if we had some sort of multi-column, key. All right, let's try this insert again. And it complains, won't let us do it. So this is the type thing that we should basically almost always use. We should almost always be using foreign key constraints to prevent us from making mistakes. Because it's not just, what if I inserted a call for a contact that doesn't exist? It's also, well, what if I deleted that contact? And then I orphaned those call records. So there's a variety of different constraints, foreign key constraints, not null constraints, even specifying a type instead of just always using text. Those are all constraints that help ensure data integrity. And that's another thing, like going all the way back to this morning where we're talking about spreadsheets. I know you can do some of that type stuff with a spreadsheet, but a database has much more powerful tools for ensuring data integrity. Okay, so we're about to jump into joins, which is kind of a major new concept here. But before we do that, let me just, pause, see if we have any questions on the stuff we just covered.
Could you just say again real quick what the foreign key does?
Yes, so the foreign key constraint ensures that, like in this particular case here, a call has a contact ID that says, this call that started, on May 23rd and it lasted 1 hour, it was to contact, 99999. The foreign key constraint ensures that the ID that we're referencing actually exists. So it prevents us from recording this call because we're referencing a non-existent contact.
I think this is actually a good example of why understanding SQL is really useful. My background is Rails, like the Django of Ruby, and foreign key constraints aren't really used a whole lot for code bases that use the ORM heavily. So I think the idea is well, if you're doing it through Ruby, if you're assigning associations through Ruby, then Ruby won't let you, it won't let you assign an orphan record. But that's only one way to do it. You can also do it through SQL. You can also get into the terminal and start doing this stuff. And that's why this is an example of something like a lot of Ruby code bases don't really do this, but they should.
Yeah, because especially, and this will be true whether it's Rails or Django or whatever, running a SQL update is going to be faster than any sort of update you do through, Python or Ruby. And sometimes you'll run into something like, oh, we've got, 10 million rows in this table, and we need to make a change to all of them. Well, making that change to all of them through your application is probably going to be too slow. So you're probably going to use a SQL statement to do that. Well, that means that all the validations you wrote in Rails or Django, they don't trigger. So pushing your constraints down to the database layer is, when feasible, is a good idea. There's some constraints that are difficult, a little too difficult to be reasonable. But. All right, so one other thing with foreign keys are actually the way you join tables together. So it might also make more sense as we get into the joins, because those are commonly how we connect the rows together. So to start out with, we are going to start with a cross join. That is the very simplest join operation. Now, if we run this, let's just look at this for a moment. and see if we notice anything. So what comes to my mind, first of all, is the columns on the right are all the same. And they stay all the same for like the first like 18, 19 rows. And then they change, and then they stay the same again. And then they change, and then they stay the same again. It's kind of interesting. And also our names on the left, well, they repeat every so often. You know, we got Lydia here, and we got Lydia again. And we got Lydia again. And we got Lydia again. Huh. Also interesting, we got 76 rows that came back. And I wonder how many contacts we have. Oh, we have 19 contacts. I wonder how many calls we have. 4. 76, 19, and 4. Huh. Seems to be a little bit of a connection between those numbers. So what cross join means is it says take every row from the table on the left. Now in this case, it might be a little clearer to see this if we actually did this side by side rather than breaking it up there. But it says take every row from the table on the left and take every row from the table on the right and give us every single combination of it. So what we have here is we have these 4 like calls here. If we go back to this thing here, we notice like here's every row on the left is matched to the first call on the right. Then every row on the left again is matched to the second call. Then every row again to the third, and every row again, so on and so on. Yeah, I noticed somebody just mentioned basically a nested loop. Yeah, actually it is. In fact, it's practically guaranteed that something like that is going on deep in the depths of Postgres somewhere. Oh, and colors. Yeah, so I don't know if you all are familiar with the concept of a pager. So if you ever used like less, there's a pager called, what is it called? PG, is it PG page? I'm blanking on what it's called now, but somebody wrote a pager just for Postgres. So that's what's giving me those blue colors and the ability to scroll nicely through it and all that. That'll be another thing that when we look at how to customize Peaceful, we can look at that quick then. Let's see here. So cross join means every possible combination of the rows on the left and right. That's rarely actually what we want. Usually we want an inner join. And I have inner in parentheses here because it's an optional keyword. You know, you can say that and it'll work the same way, but why type extra words if you don't need to? So typically you just say this join that. So let's run this and see what it looks like. Then we'll explain what actually happened. Okay, this is different. So what this does, we say contacts join calls on. So what the on is it's basically just like the where clause, only since it's here, it functions the same way on a inner join anyway. But what this is doing is it's saying all those 76 original options we had here, it is going to go through and say, okay, does contacts ID, so that is this thing right here. Can you all see my mouse pointer through Zoom? Does that show up or not?
Yes.
Yeah.
It does. Okay, great. I wanted to make sure when I'm pointing to something, if nobody can see it, that would be kind of unhelpful. Okay, so this column here is the contacts.id. So we're saying, does contacts.id equal calls.contactID? It does. So this row is going to be include. Next row here, next possible row. Does the contacts ID equal the contact ID? No, it doesn't. So this row is going to be rejected. Does this equal this? No, so it's going to be rejected, and so on and so on. Reject, 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 all the way up to this one when, oh, we have another match. This one will be included. And then it keeps going through all these, and it ends up rejecting 72 out of those 76 possible rows and including the 4 of them. So I definitely encourage questions when we're talking about joins, because getting the mental model for how these work is like really, really important. And that's why we started with the cross join, even though we don't really use it, because that is kind of the way to visualize it. We start with all possible combinations and we filter them down with the on clause. And later on, when we talk about left joins, then we also have a little bit different behavior there, but we can kind of picture it all from every combination of how these rows could be combined. So any questions on that?
I wanted to ask about like the difference between inner join and left join, but if you're going to go into that later, I can wait for that.
Sure. Yeah, I'll give you the 15-second overview, and then we'll go into it in detail later. So left join lets us say, I want a row on the left, even if there was no row on the right. But yeah, we'll give you we'll have a good example of that. Let's see, actually, yeah, I think we'll probably get to that just before lunch, if not right after lunch. Okay, so now that we have some simple joins, we're going to segue a little bit into aggregate functions. So aggregate functions reduce multiple rows into one. Depending on how far you are in Python or JavaScript, you may run into a concept called like map reduce. In particular, the reduce part, if you see a reduce function, it's basically the same thing as aggregate functions in SQL. You use it for the same thing anyway. So let's just run a couple of these and see what happens. So we're going to say select star from calls. And we don't get 4 rows anymore. We get a single row that says 4. So the count function aggregates every row that comes in, it increments a counter inside it. And the star is kind of a special form that says count the number of rows, because to be pedantic and precise, count counts the number of non-null values for whatever that's worth to you now. It can be useful at some points, but most of the time when you just say count star, you're saying, give me the number of rows. And then, okay, how about some call duration? So let's just look at that. All right, so you can probably, I mean, it's somewhat intuitive there what is actually happening, but let's talk about like how it's happening. So if we just said select call duration and we did not do the sum, we get these 4 rows here. What sum does, it's an aggregate function. So every one of these rows gets passed into that aggregate function. And the aggregate function has internal state where it keeps track of it. So first row goes in and it says, oh, well, it's now 3 minutes and 23 seconds. The next row comes in and it adds this 7 minutes and 2 seconds, and we end up with, what is that, 10 minutes and 25 seconds. And I'm not going to try and do the rest of the math in my head. You get the idea. Every row that gets passed into it gets added to that accumulator, would be the term for it. And we have a similar thing with average. You know, we can, internally an average is do the sum and do the count and then divide at the end. Is essentially what that boils down to. But that idea of your aggregate function, having a like an internal accumulator, that's a pretty big deal. And it gets more interesting when we add the group by clause. So what if we want to know how many times we talked to each person? So this tells us we had 3 calls with contact ID 2 and 1 call with contact ID 1. Now, if we were to remove the group by and we were to remove the count, just so we have our original underlying data. Again, we want to get this mental model of like what is actually happening here. So the way that SQL statement here worked is it looked at each one of these rows here. The first one that came in was contact ID 1. So it said, okay, contact ID 1, I'm grouping by contact ID. So I need to create a new group or a new bucket to store all the information about contact ID 1. It says, do I have a group for contact ID 1? I don't. So the first thing it does is create a group for contact ID 1. And then what do I do with that group? Well, I'm counting stuff. So I'm going to increment that counter. It started at 0, it's now 1. All right, now next row. Next row is contact ID 2. We say, do I have a group or a bucket for all the stuff that deals with contact ID 2? I don't, so I better create one. So I now create a new bucket or a new group for contact ID 2. Now that group or bucket, the count starts at 0. So now I feed this row into it. Now the count is 1. So if we wanted to, we could say we have contact ID 1 equals 1, and contact ID 2, count 1. Now the next row comes in, and we say, okay, contact ID 2, do I have a bucket or a group for that? I do. So all I do is increment the count. Then we come here, okay, contact ID 2 again. Do I have a group? I do. Let's increment the count again. And we end up with contact ID 1 has count 1. Contact ID 2 has count 3. And you'll notice that this, again, we did not have an order by clause. So to review that idea of without an order by clause, the order is arbitrary. Why did it decide to put it in that order? Who knows? Probably it ran into contact ID 2 first, but it really doesn't matter. If we cared about the order, we would have to specify it. Okay, does that make a little bit of sense anyway? Cool. So yeah, aggregates, they reduce the rows, they reduce potentially many rows down to 1. And group by says, or I guess the way I think about it is the aggregate function, every group gets reduced by the aggregate function to a single row. And group by decides which group each of the original rows goes into. Now, here's the thing. Every selected column must be either in the group by or must be in an aggregate function. So we're going to run this thing and it's going to whine. This is a good error message in that it tells us exactly, technically, the problem. When you're just starting out, it's not that good though, because it doesn't really tell us why. So let's talk about this. Why can't this work? So we're grouping by contact ID. So we're saying, okay, I want the contact ID. I want to know when the call started, and I want to know how many calls there were. So let's look at all calls again. So we're grouping by contact ID. So we're only going to have 2 rows that come out because we only have contact ID 1 and 2. And we're counting the rows, so that's fine. What is the call start for contact ID 2?
There's a bunch of them.
Exactly. There's a bunch of them and we're trying to squash them down to a single row. And Postgres says, hey, you didn't tell me what to do here. I can't do this. So Postgres will reject this query. We either have to group it, like we could add a group by. Now that would be kind of useless here because every row would be in a new group. Or there are other aggregate functions, like we could say, when did I first talk to this person? Maybe that would be a meaningful question to ask. So like if we did that, now call start is an aggregate function. And we now just get when was the first one or when was the smallest one. We could say min, we could say max. There's various things there. But just that fundamental idea of we have many things and we're squashing them down to one thing, we have to tell it how to do that squashing or that reducing every time. Otherwise, it's going to throw an error. That is an example. I mentioned that SQL is a common language, but there are like various dialects. This is an example where the dialects can differ a little bit. Postgres is strict. If you run this query as we saw, it throws an error. Historically, anyway, this may have changed. I haven't used MySQL in any serious capacity for quite a number of years now. But historically, MySQL would just automatically grab the first one. So it would assume, oh, well, in this case, you must just want the first one. And that's the type thing you'll really run into if you have to go between database engines, where the core SQL is the same, but edge cases are handled differently. You know, Postgres tends to be strict. MySQL historically tended to be lax and just kind of assume what you wanted, and it was sometimes even right. Okay, any questions on that? All right, let's just try a couple more example things here and then we'll break for lunch. So this is just an example. You can use multiple aggregate functions in a single query. I mean, why wouldn't you? But just to be explicit, you can do this. And you can also do a join with an aggregate function at the same time. This is actually really useful because, you know, aggregating like, oh, we talked to contact ID 2 for 52 minutes isn't especially useful for me as a human. Knowing as a human, oh, I talked to 52 minutes with Shirley, well, that's a little more meaningful. So this idea of we're going to join records, you know, and then group the aggregate together, that is important. And the idea of what order this happens in, that is also pretty important. So the from clause actually happens first. So if we were to try and visualize how does this query work, well, we could go all the way back to, let's see if I can find this. Yeah, this query here. This part happens first. And if we wanted to go like all the way back, we could even say that the kind of the cross join, we start here. That's how we visualize this first. Then we actually were doing a normal inner join instead of a cross join. So we started with these 76 rows, but then the join condition here filtered it down to these 4 rows. Then we decided for every one of those rows, we are going to make a new bucket or a new group based on contact ID and contact name. This is another place, just like order by and we'll select, where you can have a list of expressions that define the group. And this is another one here, yeah. Just like all those other places, these are expressions. Now your expressions are almost always a column name, but you totally could say, you know, group by the length of the contact name or something. Now, obviously that's not terribly meaningful, but sometimes something like that is handy. So we get these 4 things, then we say, okay, we're going to group by. So now we're going to feed every one of these rows into the aggregate, and we're going to choose which group or which bucket based on these 2 values. So that would be, you know, this column here and this column here. And then for each row that comes out of that, you know, or every row that comes in, we're going to do the count, we're going to do the sum call duration, we're going to do the average call duration. And these are part of the bucket. So we are grouping by that. So we can do that. And, you know, we end up with this final output there. All right, any questions?
I had a question actually.
Okay.
I'm just curious, and on line 186, you use the on clause, or I don't know if that's what you'd call that, a clause. Yeah. You could use the where clause there, right?
Yes.
Use it. What's the difference between like on and where?
Okay, great question. So one, if we use join specifically, like if we were just to do this, this is going to give us a syntax error because I need to learn how to use the mouse, I think. This will give us a syntax error because join requires an on clause. Not a terribly helpful error, just, hey, something went wrong near where. That's not super helpful. So we would actually have to use a cross join here. But yes, this will work exactly the same way. If you look at quite old SQL material, like probably 15, 20 years old or more, you'll see a comma is shorthand for cross join. Sometimes it's also just called a comma join. So you would see something like this in like an old SQL textbook. And this will actually work the same way as well. So again, comma is basically an alias for cross join, and cross join with where does work the same way as join with on. So functionally, there is no difference. But for the developer, there is a difference. So the difference for us is the on clause is giving us a hint for the meaning. So the meaning of this condition is to constrain the join between contacts and calls. The meaning of a where clause, you know, something like that, the meaning of the where clause is to filter the rows after it's joined. So again, technically they can work exactly the same, but it gives additional meaning to the developer as to what it conveys intent, would maybe be the best way to put it.
Okay, thank you.
Mm-hmm.
Jack, that one thing I think is worth mentioning about SQL, I'll try to describe this, correct me if I'm wrong, but SQL is a little bit unusual because it's like, it's a language, right? But what are we writing right now? Are we writing SQL? Well, we're sort of writing SQL, we're writing Postgres SQL. What's that all about? The way I would describe that is SQL is like a standard. It's a standard that's defined by a body, right? Like a standards body. And I don't know where the SQL HQ is.
An ISO group that does that.
Yeah, in an ISO group, what does that mean?
International Standards Organization. I don't know if it's actually like part of the UN or something like that, but it's some international body.
Yeah, so there's these academics and computer scientists who like get together and say, this is what SQL should be. And then, and they are constantly updating that and evolving it. They're saying, now we want SQL to do this. Now we want SQL to do that. And each implementation of SQL, like Postgres, you know, is trying to keep up, and they're all doing different quality jobs, like implementing that standard. So that's why you'll see, like, if you hold like MySQL up against Postgres, you know, you'll say like, well, why does it do this and this one doesn't yet do that? But then a year later, it will start to do that. It's because each open source project is trying to like live up to those standards.
Yeah. Yeah, and Postgres is usually considered just about the best for standards compliance. But even Postgres, like there are parts of the standard that were defined like 20 years ago that like nobody's ever implemented. Because it turns out academics come up with ideas that actually like can't be implemented sometimes too. So it's actually kind of funny. But yeah, you just end up with like different dialects. They all in theory are based on this standard.
And that's different from like a language like Ruby, where there's a single person basically who created it and is like has the ultimate say on the direction the language goes. And when Ruby adds a feature, Ruby adds a feature. SQL doesn't work that way.
Right. Yeah, so there are definitely some things in Postgres that like only Postgres does this, because they invented a new feature and then that means they had to come up with the syntax for it. And there are things that the SQL standard has that Postgres doesn't have, and there are things that they do a little differently. But yeah. All righty. Well, I don't know about you all, but I am famished and I am ready for lunch. So let's take a break till, we'll take an hour break, I guess. So we'll come back at 10 after 1. We are going to start looking at left joins now. Continue where we are just before. Left joins come in when we want to find a join where the right side is missing. So like in this one here, what if we wanted to include contacts who had no calls? So we'll start by doing a left join without the group by, so we can see what's happening here. So we are going to pull this into a new file for a second here. And take out that. Okay, so what's happening here? We have the 4 matches on top that are the same as when we do an inner join. But we also have all these other matches here. Now, this symbol here is actually what I have set up to display null. So actually, all of these are null. So what's happening is we have all the contacts and we try to join with calls based on contacts ID equals calls.contact ID. But if we don't have a match, we still want to return the row. We just leave all the columns from calls empty. Yay, nay? Okay. Now, starting from this, result here that's not grouped, if we add the group, and we want to see how many times did we talk to everybody and include the people we didn't talk to at all, we can run this. Except that's not quite right, is it? So all these people we didn't talk to at all, the sum and average are null, which is good enough, I guess. But count 1. What is going on there? That's not quite right. So what's going on here is, if you remember when we talked about count star being kind of like a special form that counts the number of rows. Well, when we go back to what we had before here, there is a row here. John Smith, we may never have talked to him, but there is a row. So it is correct for the count to say 1. In other words, what happened here is Postgres gave us the right answer to the wrong question. So this is one of the problems we run into as we do more advanced SQL stuff. At the beginning, it's like, okay, it ran, it must work. And then you start to realize, wait a second, it gave me an answer, but did I ask the right question? And in this case, if we want to know how many times we talked to the given person, we're not asking the right question. What we need to do here is, instead of counting the number of rows, we want to count one of these columns, like calls.id, and count will only include non-null values. So if we say count calls.id, well, if we look back to our ungrouped one, calls.id is null for all of these. So we end up with zeros. Now let's talk a little bit about what exactly is null. We already talked before about null being one of its meanings being empty. And we said that there was more to it, and unfortunately there is. In Ruby or Python or Go or most any language, nil is just, all it means is absent. But in Postgres and SQL in general, null has another meaning. Null means unknown. And unknown is kind of a infectious or viral value. It infects everything around it. So here's an example of where null gets really, really weird. So let's start by saying, does 1 equal 1? Well, if we ask Postgres to evaluate this, it's going to give us back t, or true. And if we say, does 1 equal 0? It's going to give us back false. Makes sense, right? Nothing crazy there. What about if we say, does null equal null? It's not true or false. It's null. What if we say, does 1 equal null? Well, that's strange. I mean, it seems to me 1 is definitely not null. How can it say null? I mean, that seems like it should be false, but instead it's null. And here's the reason why. Let me stop screen sharing for just a second here so you can all see me on screen. So I have something in my hands, or maybe I don't, who knows? Is what I have in my left hand equal to what's in my right hand?
Yes.
How do you know?
I don't know.
It
Don't
might
know.
be equal. Yeah. The only real answer is I don't know. Now in this case, no, they're not equal. I got a thumb drive and an SSD, I guess what I happen to have laying on my desk right now. But one hand could have been empty. They could have had the same thing. They might not have had the same thing. So when you say, does null equal null, what you're really asking it is, I have a box that I don't know what's in it. And I have another box that I don't know what's in it. And I want to know if the contents of the boxes are equal. There's just no way to know. And when you compare, I know what something is over here. I know it's the number 42. And I want to say, is 42 equal to this thing, this unknown thing in the box? Well, it might be. We don't know. So basically, anytime you see a null, anytime you compare it with something, the answer is null or unknown. So anytime you have an unknown value in your equation, it infects the whole thing. So the answer becomes unknown. Now there is a little bit of a way around that. So the coalesce function, there's a few functions which handle null specially. So coalesce says, if the first argument is null, then return the second argument. So in this case here, it doesn't really make sense to say we talked for null amount of time to the people that we didn't have any calls with. So we're going to coalesce and just say, okay, if it's null, we're just going to coalesce it to all zeros for an interval of 0 amount of time. So to be precise, coalesce is a variadic function. It takes any number of arguments, and it just returns the first one that is not null. In general, you may have noticed that, like, when Jake was showing like that entity relationship diagram, that a whole lot of those things were not null. And when we've done the \d, there's a lot of not nulls. The reason for that is null is just too tricky. So anytime we can, we always want to restrict it, because it's just an extra layer of confusion. And okay, it makes sense, like if you're saying select 1 equals null. Okay, I understand what's happening here. But what if it's select 1 equals, some column, and you don't realize, or you're not thinking at the time, oh, there could be a null there. And you say, well, wait, why did that not match?
Hey, Jack, you're not showing your screen anymore. If you're...
Oh, nuts. I'm sorry. Sorry about that. Let's see here. Okay, here we go. So yeah, this okay, you see, is it working now?
Yes, sir.
Yep.
Yes.
Okay, great. Yeah, so this like select 1 equals null makes sense, or at least if you keep that in mind of unknown. Oh, and by the way, the not equal in SQL is that whole less than, greater than diamond operator thing. So that's a little different than Python or whatever. So yeah, is 1 not equal to 2? True. Is 1 not equal to null? No. And that kind of makes sense, but the problem is, like, if we had is 1 not equal to, some column, well, that gets really confusing, or it can be really confusing. So yeah, avoid null whenever possible, but you can use coalesce to change a null value to some arbitrary value if you deem it necessary. And there's a few other conditionals, just like there's equal. There is a version of equal that treats null. Normally it's called like is distinct from, is not distinct from, for not equal and equal. But it's very, very rare you actually need to use that. So we covered 2 pretty important things fairly quick there. We covered left joins and we covered more detail on null. Anybody have any questions on that? No, that's definitely a tricky subject. All right. Either everybody's asleep or this is a really smart class. So. Okay, well, before we get into the next like major lesson section, one of the things Jake and I usually do at some point is kind of just talk about a bunch of the different things you can customize in P-School. And I'm gonna show you a few of those things, and I think Jake will probably want to jump in at some point and show you some of his customizations and whatnot. But you notice how like mine always shows time? Well, you turn that on by saying \timing, and it toggles whether to show the time or not. So like without timing, with timing. And we also note that, this probably looks a little different than the prompt you have. So there is a file that you can create in your home directory, .psqlrc. Anything in that file will run automatically every time you start up P-School. So in particular, what I have here is I turn on verbose errors. So that's why when we ran into an error, I had like a whole bunch more lines of code, most of it kind of useless perhaps for our purposes, but this says, give me more verbose errors. This says if I'm running a script and the script has an error, stop. By default, it'll just keep going. This tells me, this tells it, tell me how long it takes every time I run a query. This command says, like when you all ran these queries and you got a null result, it didn't print anything, right? It was just entirely blank. Well, the reason I have this thing here to show that weird like math 0 with a cross through it symbol, whatever that actually is technically called, is I want to be able to see the difference for if this is null or if this is an empty string. And without that, they look the same when you run it in P-School. Then as far as that, you know, the reason when I run a P-School thing and it needs to scroll, it has that blue stuff and I can arrow through it. This was the pager I was talking about. It's called PSPG. And there's a variable you can set for P-School to say, use this pager. And then I tell it to use nice little Unicode characters to draw the borders of the tables. And finally, this line noise here, this is actually what's setting the prompt. So I couldn't begin to remember what all these things are. I figured this out and got it working, you know, years ago and haven't really touched it since, but looks like you can kind of see here, like, if you remember like printf stuff from C, or I think Python probably has the same thing where you have like a format string. So yeah, this whole, that's probably name at, and then probably the socket or network connection, colon, that's probably the port or something in there. And then these weird things here are what changes the colors, different things like that. It's a real mess. You probably just, if you want one of those, you probably just want to Google it and find it rather than have to write one of those by hand. But anyway, this is how you can just run arbitrary code whenever you start P-School. And I mean, it really can be arbitrary. You could just put, you know, really anything there. But this is the type of stuff that makes sense. Let's see here. Let me start this again. I think there was some other stuff we usually ended up talking about at this point, Jake. Do you have anything you want to jump in on there? Or I think you usually go through the help stuff a little bit, but
I think my P-SQL RC is a lot like yours. Yeah, the help command's great. Actually, yeah, what did you just type? I didn't see. Yeah. So \help, and if you do it without a keyword, then it just shows like a help menu of all the things that it could tell you about. And then if you do any of the type in any of those commands, it will tell you more. And this is, I think, just so this is interesting information, right? Like, let's go to one that's really boring. What are you looking at now? Okay, how about select?
that's actually a pretty, there's a lot to select.
Okay. Good point. Well, let's look at select. So this is a, I might have written about this in our repo somewhere, but this is a syntax for explaining how the command works that can be really hard to read, but explains comprehensively like what the command does. So you've got a description, and then you've got a syntax, and then yeah, is there a simpler one we could look at, Jack? What's the,
Yeah, let's see here. Maybe,
how about
let's see here. Insert actually might be simpler, or maybe probably an alter would be pretty simple. Maybe
sure,
like,
alter's great.
yeah, like alter role maybe.
Sure.
Yeah, that's a lot. That's a
Yes.
lot simpler.
Yeah, so it's alter, role. Those are the two SQL keywords, and then something called role specification. We'll have to figure out what that is. And then with is in brackets, which I think means it's optional. And then option is a list, and you see an array there with a dot, dot, dot. So it shows you those are all the different options. And then if we scroll down, we'll probably find out what role specification it can be: current role, current user, session user. So if you needed to change the role of somebody, you could look at this and say, okay, I want to do alter role and then current user perhaps. So, and then if you scroll back up to the options, you know, so I could say alter role current user with super user maybe. And there's a couple other things in there. We have a vertical line that's or. So these, it's one or all of these. And then this syntax is a little tricky, but it's good to try to read it because it actually contains the full, you know, a pretty full explanation of how the keyword works. And I'm always advocating doing this stuff in the REPL or in the terminal if you're doing command line things, because you know this is the documentation for the version that you have. Some of you are on like Postgres 12 or something, or Postgres 10. Well, it's a little bit tricky online to find the documentation for the version you have, and it's actually a lot of those websites are optimized to show you the latest documentation. You have to dig to find older documentation, but your Postgres on your machine is actually all it knows how to show you is the version that it has. So I think earlier I shared something from P-SQL, and that came from a man page. I don't know if you all have done much manual diving yet, but if you have a command line executable, there's generally a man page. You type man and then the command, and then you can search through this. We're in a pager of sorts right now. So like if you type like /-f, you know, that's how I found that the answer to that question is it highlights every time that's mentioned, including the time where it actually matters, where the file name command. And then I just sort of scrolled down and saw using this option is subtly different from writing P-SQL arrow file name, and that was the answer. So yeah, if you can look in the terminal, you know, always look in the terminal, or always look in the documentation for your language.
Yeah. Yeah, there's a bunch of stuff here, and like the backslash to see like all the backslash commands. Like this is kind of interesting, like it even has watch. So like if we did like, what time is it now? We could run /watch and it'll like just run this query over and over, like every 2 seconds. You can tell it how often, but defaults to every 2 seconds. And that can be interesting when you're just trying to figure out like an ongoing process, like what's happening, or some sort of, you know, primitive dashboard type thing. You hit Control-C when you're done.
Have you all looked at dot files much, or talked about dot files? I guess it's just sort of an intro, if not. Dot files are great. So for pretty much any program that runs on your machine, there's a dot file. They're usually, they have a convention of like dot program RC, which stands for, God, I looked this up, read configuration or something. But it's a really great way to like make your Python or your Ruby act the way you want it to act on your computer. And I don't know if Jack does this, but a lot of devs I know, including me, like have these checked into a repository. So if I get a new computer, I just clone this repository onto that computer, and like all the languages are set up the way I want them.
Yeah, there's a bunch of cool things you can do there. Like with Git, like you can configure Git globally. Yeah, speaking of using DAT files long terms, you can see I've been using this DAT file for a while. Go to 1204. Yeah, it's been a while. Okay, anyway, yeah, most command line tools have a DAT file where you can like configure them. So, all right, let's get back to directly on SQL here. Oh, let's see here. We've got multiple different projects we can do. Let's do the weather one. That's probably the simplest one. So let's open up lesson.sql in the weather directory. And we'll need to change directory to that weather one. And we are going to run this command, create DB weather. And what do you know, I already have it. So we'll drop that DB, recreate it. And let's see here. Let's see. So we create weather, then we're going to run this file. And then let's start running psql weather. So let's just explore and see what we got first. If we run \d, it's going to list all the relations in this database. And relations encompasses more than just tables. Like you'll notice this sequence here, which we probably really don't care about. So if you do \dt, that says only show me tables. So we can see we have two tables. Let's see what the structure of those tables is, or are. So reports. Okay, so we have an ID, station ID, time. That's a timestamp without time zone. That's interesting why it's without for some reason. Temp F, which presumably would be Fahrenheit, humidity, wind speed, wind direction. Okay. What about the other one? All right, so we have an integer for an ID again. We have the name. We have the elevation and Latin long of the weather station. So let's just look around a little bit. Let's look at the stations. So we have two stations here. From the NOAA, you can get like a ton of different information, but it also is kind of like big. So I ended up selecting just Jacksonville and Chicago because when we first did this, Jake and I were part of HashRocket, and HashRocket's headquarters is in Jacksonville and our office was in Chicago. So it seemed like a couple reasonable places to focus on. And let's look at our reports. Let's just see what we got here. All right, so we've got a lot of reports. Okay, interesting. Just kind of scroll through a little bit, see, oh, this is really cold. January 3rd. And okay, looks like there's a lot of them here. So in your pager, if you hit Shift G, this will work even in your regular list. That goes to the bottom for what that's worth. So it looks like we've got 220,000 rows. That's a lot of data. All right. How about for our first exercise here, we just try and find out which weather station has the highest temperature. So where was it hottest? Was it hottest in our records here? Is it hottest at one point in Florida or in Chicago?
Florida.
Hmm? So there's a few different ways we could approach this, this problem. I'm going to say that probably the simplest way to start with anyway is if we look at the reports. So we have our select star from reports. If we were to order by the temperature. Okay, well, that's the coldest first. So we're ordering the wrong direction. All right. So let's order by temperature descending. Okay, it looks like 103 is the warmest, and we registered that on both, what is that, July 5th and 6th of 2012. Now, station ID isn't terribly useful there. So it might be nice if we, maybe joined with stations. All right, so how about that? It's hotter in Chicago than it is on the coast. It's interesting. Might have expected Florida to be warmer than Chicago, but apparently not during summer. And if what we could do here is we could also do a limit 1, make this run a little faster. Notice that that runs in 54 milliseconds. If we don't do the limit and we get them all, it runs in 344. So obviously that makes a little bit of a difference. If we know how to get the warmest, obviously we can figure out how to get the coldest. And that's definitely no surprise that that would be Chicago. Now this third exercise here, this is a little slightly trickier. So we want the hottest and the coldest record for each station. And we want to do that in a single query. Now, to give you a kind of like a hint of what direction to go here, we've got 200,000 rows, but we want to look at each one of those to find the highest and lowest, but we only want 2 rows to come out. So we're reducing 200,000 rows to 2. So that's making me think we're going to be grouping by something. And when we say we want something for each something, well, that something over here, station, that's probably going to be what we're going to group by. And for this hottest and coldest, well, that kind of sounds like min and max. So we're going to want to group by station, and we're going to want to use an aggregate function of min and max. So maybe something like this. Is that making sense, or got any questions on this? It's a little bit of review, but it's one of the first times we're actually using it from scratch. So I expect that it's a little confusing first 2 times you see it.
Yeah, Jack, do you mind going over that command right there and just what it's doing when it's joining those 2 lists or tables, excuse me?
Sure. Let me put this in another document here. And I am going to save this as SQL, just a temp file here. Get our nice syntax highlighting. And then this is an example of that idea of maybe we want to use the multiple lines. So this is kind of hard to read. So this is where, okay, first of all, let's just break it down where the primary clauses we put on their own line. And then generally, I like putting each join, something like this. Since the select is narrow enough here, I'd probably leave it this way. But if we end up with something where you have like 20 columns, then I usually end up doing something like this, just to make it even easier to read in that case. It doesn't really matter here, but I'll leave it this way. Okay, so to explain what we're doing, remember we talked about that SQL actually runs kind of in the wrong order. So as far as what's actually happening here, we start with from. So we're saying from reports. So that's the first table we're going to work on. We're going to grab the reports table. Then we're going to join with the stations table. Now, so we've got all the rows in reports and we have all the rows in stations. And the on clause says, how do we connect those together? So for all possible combinations, we want to keep the rows where this is equal or where this is true. And we want to reject the rows where it's false. So we've got like, if we looked at stations again, we have an ID number for each station. And if we looked at the reports again, I'll just limit this just to 10, just to not scroll so much. We can see that, this station here matches to O'Hare. And we would not want to, it would not match to Jacksonville. So this accepts the ones where this matches with this, and it rejects trying to match it with Jacksonville.
Hey, real quick, Jack. So does it matter the order that we put when we're doing a join, right? We put reports.station ID because our from was for reports, even though we're referencing stations at the beginning of the call.
So there's a couple aspects to that. So if you're asking specifically about the on clause, does the order of the fields matter here? It does not matter. As a convention, I like, just personally as a developer, I like following conventions so I have to think less. There's like so much, my brain is like really small compared to like how big all the problems are. So anytime I can come up with a convention that says I don't have to make this decision, I try and follow it. So my personal convention is the left side of the equal thing is the left table and the right side is the right table. But it'll work the same either way. I've just have adopted that convention because otherwise, as soon as I get here, I think, which one should I type first? And I don't want to have to ever ask myself that question. So I just decided I'm always going to do the left one first.
Thank you.
Mm-hmm. Now, as far as like, does this order matter of the tables? In the case of just one join like this, one inner join, it does not matter. If we were using a left join, it would matter because which one is on the left, makes a difference. And for what it's worth, there is also something called a right join, which is exactly the same thing as a left, except it's from the right instead of from the left. And there's some other like unusual ones, like there's full outer join, and there's a handful of those which the order may or may not matter, but regular inner join and left join is like 98% of what you use on a regular basis. So after we do this join, so we have all 200,000 rows and we have them joined together. So we have the report and we also know which station it was. So every one of those rows is going to get fed into the aggregate thing. We're doing a group by, so we're going to have a group for each station name. And the first time we see Chicago O'Hare International Airport, we create a group for it. And the first time we see Jacksonville, we create a group for it. And then every row gets fed into that. And for each one of these aggregates, it has, I'll just generically say it's accumulator. I guess might name it a little bit differently with min and max, but it says, okay, what is the smallest number I've seen so far? Like when we're feeding in here, okay, the smallest number I've seen is 9. And then the next one, oh, it's still 9. Then, oh, there's an 8. So I guess now the smallest number I've seen is 8. And then it sees a 7, like, oh, now the smallest number I've seen is 7. And it keeps going here. It's like, oh, the smallest number I've seen is 5. And then it sees a 7, it's like, oh, well, 7's bigger than 5, so I'm still at 5. And each one of these aggregates has its own like internal state or accumulator that keeps track of it for each group. Does that make sense, or do we need any more explanation, or maybe it
Yeah, that
doesn't?
makes sense. Thank you.
Yeah. Can I ask something related? I saw in the solutions, instead of doing group by stations.name, you have group by one. Is there a difference in that, or like an argument for why you'd use one over the other?
Sure. So with yeah, where was it, that one? Oh yeah, did it here. Okay. So if you pass a number, or I say pass, if you use a number as a group by, what that means is group by that column. So you probably actually already guessed that, but that's what this is saying. It's group by column 1, which happens to be station's name. So the reasons you do this is, in this case, I was just doing it just to save a little bit of typing and, to introduce like other ways of doing it, just so you at least see it once. So it's confusing now when you can ask questions, and not confusing later when you can't ask questions. Where it really comes in handy is, to get back to that word I use a lot, of expressions. Sometimes we're not going to group by something as simple as one column. Sometimes we're going to group by some complicated formula, and we're going to use that complicated formula in the select. And if we were to have to retype the whole thing, well, one, that's kind of annoying, and two, it might even get out of sync where that criteria changes and we remember to change it in one spot and we forget to change it in another, and that would be a mess. So if it's a complicated expression we're grouping by, then I actually prefer to use the number, because that ensures I don't make a mistake with having to update stuff 2 times. That reminds me of an expression you might hear, may have already heard it. If not, I get to be the lucky one to tell you about it first. There's something called DRY, D-R-Y. I don't know if that's been introduced or not, but it stands for don't repeat yourself. And the idea is, anytime you have some logic or some data or something that is going to be repeated identically in multiple places, you really want to avoid doing that as much as possible. Because if you're repeating yourself, whenever you have to change it, you have to change it multiple places. And that's a little bit of extra work, but much worse than that is, say you have the definition, like, let's say this was a query or something that has to do with like active users. Well, an active user, it might just be a Boolean field called active, but there might also be something a lot more complicated, like you might have an active date range, and there might be, some is their bill paid and so on. And if you had to repeat that every time you check, is this user active? Well, then the next time there's a new criteria, you might end up missing one of them. And that can be pretty unfortunate. So anyway, that's just a little aside there. But yeah, group by one, for what it's worth, that also works with order by. So if you just want to do a quick sort, sometimes you just say order by 1, 2 or something like that to order by the first couple of columns. Generally, people prefer style-wise to spell stuff out and stuff that's going to be long-lived, and you can use numbers more when it's just like just experimental stuff where you're just writing a query to look something up and then you're never going to use it again. But yeah, that's what the numbers mean in group by and order by.
Okay, thank you.
You're welcome. Any other questions? Okay, yeah, I just see that nothing has been repeated as much as keep your code dry. Yeah, so I guess you guys have heard of it before. Yeah, and in fact, if you want to get a little more in depth on that, one of the things that I think Jake and I even talked about this back when we were working together like 5 years ago, but our rule of thumb was you dry something up when you see it 3 times as far as code goes. So if you see it once, don't try and be clever. If you see it twice, still don't be clever yet, just copy and paste. When you see it 3 times, now you know enough to extract it and dry it up. But anyway.
Jack, they actually, there's a term for that. It's called wet. So dry is don't repeat yourself. Wet is write everything twice.
Oh, nice. Yeah, that's a good one. Cool. So one other thing that is going to start to make sense here, when we have a query like this one is up to like 6 lines now. So we could keep copy and pasting this, and we do sometimes, but it might be nicer if we could just run this directly. So one of those backslash commands, it's \I, and that's for like input, and we can just give it a file. So typically what I do when I'm writing a query is I'll have it open in a file. I usually call it t.sql for temp. And occasionally if I have a bunch of them going on, I'll have like T2, T3, T4, whatever. And then just run it repeatedly here and go back and change it. And then you get the advantage of having your syntax highlighting, you get your editor. Like I'm using VS Code here, but I have it in Vim mode, so I can, do fun stuff with Vim, save some keystrokes. All righty. Let's see. Let's get back here. Okay. This next one is an interesting question. Can we find the average wind speed for each day at each station? I have a query here. There's a few new things here. We'll run it and talk about it a little bit. So we are getting an average out. Now, I guess before we get here, you're probably wondering what this : date thing is. That is how in Postgres you can do basically like a type conversion. So time is actually a time stamp, but we don't actually care about the individual time. We only care about what date it is. So we are going to say, convert that time to a date. And then that also comes in handy, that idea of being able to group by and order by just a number. This just gets a little easier here to just say group by 1, group by 2, order by 1, order by 2. So this is a syntactically valid query, but is it correct? Or maybe is it correct enough? So take a look at like the, that reports table and just glance at the data a little bit and tell me if you think that we've correctly figured out the average wind speed or not. So what do y'all think? Did our query give us the average wind speed? I think I'm getting a null response here. All right, so since nobody's speaking up, I'm guessing everybody is kind of a little unsure. So let's talk about it.
Definitely unsure.
Okay, perfect. Okay, well, this is good because this is an interesting one to talk about. So let's look at the raw underlying data here. So for this station 94,000 or whatever, whichever one that one is, on January 1st, 2010, we've got a bunch of samples, which that word actually tells us a lot right there as far as can we do this correctly. We have a lot of samples. Are these samples evenly distributed? Not exactly. That's interesting. I wonder if there's any maybe samples that are missing. This might be interesting. What if we were to do something like, you know what? I talked about using that t.sql. I'm going to use that. I don't want to have to type too much in here. Let's see here. So yeah, we'll do something like this. Yeah, let's add a count here. Whoops. Oh, wow, that's what happens when you do Control Z. Apparently. Wow. So, okay. Well, that tells us at the very least we don't have a uniform distribution of samples, because it seems like every day we get some different number of them for some reason. And we already saw from looking at our first day that the samples are not evenly distributed even in a single day. So this is where it's really interesting, that idea of, is this correct enough or not? Well, the answer is definitely going to be somewhere around where it was at some point on that day. Is that correct enough? Maybe, maybe not. Could we do any better? Not easily. That idea of we have samples here. We do not have, you know, a continuous signal. It is discrete samples, and that those samples are not uniformly distributed. You know, trying to figure out what is an average for the entire day, depending on how, you know, accurate we really care about, is going to be pretty difficult. You know, oh, I did have this right in the lesson right here, so we can see, yeah, all sorts of different numbers of samples along with the average. So maybe a different question would be easier. We could say, what was the minimum wind speed and what was the maximum wind speed we observed each day? By carefully phrasing the question we're going to ask, we can do that. And this is accurate, you know, within the bounds of exactly how we asked it. What was the minimum and maximum we observed each day? So that is not vulnerable to sampling errors. And, you know, saying we observed it doesn't imply anything about how many times we took a sample each day. Okay, here's a little exercise. can we find
Hey,
all
Jack.
of the? Sure, yeah.
Hey, sorry to interrupt. I just had a question on the previous exercise, the syntax on it. Right there. So is it convention then if you see there's reports.time : date, and then when we're putting in a aggregate, I guess, function with min or max, we're just using the name of the column. I mean, would it work if we just said time : date since it's from reports?
I believe it would in this case. Let's see here. Yeah. So what we're doing, it's actually only necessary, I suppose. In fact, it might not even be necessary at all in this query. Let's try it. So you only need to fully qualify it when there are overlapping names. So like, for example, if we wanted to do something like, if we wanted to use ID, well, the name ID is used in both queries. So we would have to qualify that. I generally qualify stuff if it's going to conflict or if I think it might conflict in the future, perhaps. But yeah, you only need to do it if it's conflicting. One other thing. Go ahead.
Would you say it's best practice to still use the other syntax just in case someone adds another table or someone adds like new data or new columns? Like, would you say it's better to just always be that specific with the whole reports.name, reports.time?
So I'm a little too lazy, or I'm a little, my fingers are a little too tired after 20 years of typing to actually want to go that far. But generally I do it if I think it's likely to be a problem. So like ID or like name is something, half the tables you write have name in them, it seems. So like name kind of makes sense. Time, maybe. I could have gone either way on that. But like wind speed is very unlikely to be in any other tables. At least, given that we only have these two tables. But what you can do, here's kind of what I actually usually do. You can alias your tables. And then that makes it a lot less onerous to do something like that. So usually, just to avoid having to type out the table name every time, I usually add an alias, especially because, these table names aren't too bad, but sometimes you end up with a table name that's like 2 or 3 words. And it's like, I just don't want to have to type that out, like for every join condition or something like that. So I usually will do like a 1 or, maybe 1, 2, 3 character alias of the table.
I believe, Jack, that syntax itself is a shorthand, right? It would be reports as are if you wanted. That's like, it's a shorter version of.
Yeah, as is an allowed optional word for aliasing tables and for aliasing columns. I usually omit it from tables, and I usually include it in columns. The reason being, what this actually does is rename the column. And it's all too easy sometimes to do something like if we did this. Well, we missed a comma. This is what we really wanted, but instead it's treating it as rename name as time. And that's a really annoying little foot gun there. But yeah, you're correct. The as for the rename or alias is allowed in both places.
Yeah, if you do have an overlapping column names, I guess, will it run and just pick a random one, or will it throw up an error?
No, it'll throw an error.
Okay, cool.
Can you go over the date and the why we are numbering the group by and order by and how those conventions work? I'm trying to get into my head.
Yeah, sure. So the date, let's just look at this. So the now function just gets the current time. And the type of column, I think, let's see if I remember this off the top of my head. I think there is a function like this. Yeah, I do remember. Okay. So the PG type of function, you pass it a value and it gives you the type of that value. So now returns a timestamp with timestone. Colon lets us change that into a different type. So for example, we can convert it to a date. It's kind of the thing we're doing here. We could convert it to text if we wanted. And we could see if we did that type of thing. And that was text. And we might want to do something like that if we say we just wanted the year. Now there's better ways to do this actually in most cases, but yeah, so the colon converts it to a different type. And we can say, convert this to an integer or convert it to a float or whatever. Might find stuff like that. Like if you do, integer stuff, maybe we really want this to actually be a float. For the group by stuff, this is the equivalent, the 1, 2. That is saying column 1, column 2. It'll work exactly the same way if we did this. But it just saves us a little typing and avoids us maybe getting inconsistent by referring to it by the column number instead.
Okay.
So Jack, are those indices of the select statement? Is that what we're looking at?
You mean the column numbers here, or?
Yeah, like the 1 and the 2.
Yeah, just select column 1, select column 2, just the 1 based instead of 0 based. That's another weird thing with SQL. It actually does 1 based things, whereas most other languages are 0 based. It's like Postgres actually has arrays and they're conveniently 1 based instead of 0 based like every other language you'll use. Okay, let's try this exercise here. This should be just a matter of adding another couple min and max on humidity and temperature to this query here. So let's just try that.
Jack, would this be maybe a good time to take a quick break?
Yeah, you're right. I didn't realize time got away from me. Yeah, let's take I guess let's take 10 minutes. Let's come back at 25 after, and we'll finish this up and then go into the data modeling thing with Jake. All right, see you in 10.
Hey, Jake, I got a question real quick.
Yeah.
Do you ever, so like, PG admin 4, whatever it's called, do you use that a lot, or is it more like not really that professional to use? I don't know if that makes sense.
I used it back when it was PG admin 3 for a little while. But honestly, I haven't really used any of them for a lot of years. I mean, I think some people, you know, they are that type tool. That's not the only one. There's a lot of like graphical tools. They can be really nice for like exploring a database. You can be a little easier there, but just personally, I haven't really used them much in a long time.
Are they common in like professional settings, or is it just user preference?
I think that really depends on the company. Like one of my old friends did like or does like SQL Server, like Microsoft SQL Server, and like they're like really big on GUI tools. So they use like one of those tools for everything. But like back at HashTrack, like Jake, I don't remember anybody using anything but T-School there. Maybe I'm mistaken, but
Yeah, I think there's, I think Jack's right that you can, some teams really use that stuff and sometimes it can be useful for certain tasks, but I think the consultancy we came out of definitely had a bias towards stuff in the terminal. We use Vim, the text editor, you know, stuff that is in the command line in the terminal. I think we had a bias towards that, and to take off the like, to step away from the like the snobby element of it, you know, the sort of like I'm a super good programmer, so I do this. Those tools are like evergreen, right? They'll always work the same way. If you learn them today, you know, you can use them in 5 years and they'll be exactly the same. GUI tools don't have that. They might not exist in 5 years, but they'll certainly be quite different. So I think there's an argument to, I'm nothing against PG admin, but I think there's an argument to like being proficient at P-SQL as well.
yeah. That type thing is never really going to be a factor in like whether you get a job or not, whether you use one tool or another for that. But
yeah, that's a great point. I think you can use VS Code like Jack's using, or you can use Vim like I'm using. Can you find a line of code in the file in the code base quickly and change it? Is like, you know, the thing that actually matters. And so if you can use PG admin to quickly answer a question about the database, awesome.
Yep. All righty, let's look at this big old query here. We're gonna kind of abbreviate the last little bit here because I don't want to chew up too much of the time for we want to get to Jake's data modeling exercise real soon now. So this big query here, this is where we start to get to that example of it really starts to make sense to have a separate file. And it starts to make sense to break stuff up line by line because just there's so much going on here. So I'm going to run this and then let's talk about what's happening here. There's a couple new things that are happening here. The first one here, this is an example of doing that conversion of date to text and then just textually saying, give me the 7 characters on the left. And we're going to use that to group by later. What this is actually doing is this is saying, you know, what was the minimum average temperature and what was the maximum average temperature for each month. So we actually need to do this kind of like in 2 levels. We need to find what was the minimum temperature for each day and what was the maximum temperature for each day. And then we average that result, you know, for the month as a whole. So this thing here, this is a new thing. This is called a subquery. So the from clause, everything we've done so far is just from table X or from table Y. But the from clause, just all its elements need to be something that returns a table result or, you know, a set of rows. But it doesn't actually have to be just a table. In this case, we can use another query as a table. So to do that, we wrap it in parentheses and we give it a name. So we've got like this initial query here. I'm going to run this down here. The result of this whole table here becomes just T. And then outside of here, you know, we can act as if this was a table. So that's a slightly more advanced technique. It's not something you're going to do every day. But when you need to do like 2 stages of calculation, this is one of the ways you would do that. Yeah, I'm just going to talk through this stuff here so we can, I want to let Jake take over in about 5 minutes or so. So I want to just talk through this. There's something called a view. So a view is another one of those things that is table-like. What a view is it's a saved query. We save the query, and then from that point on, that view can act just like a table. So I'm going to run this code for the create view. And when I run this, you'll notice it didn't actually execute the query. Instead, it said, oh, I created a view. So now I can do select star from the name of that view, daily summaries. And it's just as if I typed out this whole thing here. And then we can use that as just as if it was a table in any of our select statements. Depending on the view, you can even insert into views if it's a very simple view. Sometimes Postgres can even figure that out. And then here's that example of that original really long query rewritten just to use that view. And we'll just talk about the idea of a materialized view. A materialized view means not just does it save the query, but it actually runs it once and saves the results. So by doing that, we can have a slow query that then we have a cached copy of it that we can run really fast. Problem then is we actually need to tell it manually refresh this thing. So materialized views are something interesting to know about, but you're not likely to use for, well, a long time. So to end with a little bit of a discussion on this, what we did here and how it's going to lead into what Jake is going to lead us through, is when we're querying data, the questions we can answer are determined by what data we have available. Like we determined that we're limited to answering the question of what was the average wind speed on a given day. And we can answer the question of like highest and lowest temperature each day. You know, there's certain questions we can answer and there's certain questions we can't answer. Now, what Jake is gonna lead us through in the next segment is a data modeling exercise. And I believe that exercise is more focused on like if we were writing an application. But it works the same if it's an application or if we're writing a report. When we're designing the data model or like what tables we're going to use, we need to keep in mind, what are the questions I need to answer in the future? Maybe it's a report type stuff like, if you were doing a reservation system for meeting rooms, well, you may not care to know who reserved this 3 months ago. So maybe your data model doesn't maintain like archives. Maybe it just records who's there now. If you were doing hotel rooms, yeah, you're definitely going to want to know who was there 3 months ago. You probably have like legal requirements to record information like that. From an application point of view, do we need to know, like that TIL, that Today I Learned example that Jake talked about at the beginning of the day? Are we ever going to ask the question, how many posts has any one person done, or show me all the posts from a given person? So as kind of a backdrop to doing data modeling stuff, our data model has to be able to answer all the questions we're going to ask of it. So keeping that in mind as we thinking of the questions we're going to ask before we write the data model will help us get a better data model. And this stuff here, this weather stuff, gives us a little bit of an example of that, in that, yeah, we have all this data. There's some questions we can answer, and there's some questions we can't, because our data model just doesn't allow for certain answers to certain questions. So do we have any last questions on this before I turn this over to Jake?
Hey, can we just go over the group by one more time? Just so, like, how do you pick which columns?
Okay, so let's get another example here. So in this weather thing here, yeah, in fact, this is a great example here. How we choose which columns to group by is, first of all, let's step back and say, like, what question are we asking? So like in this particular query here, the question we're going to ask is, I want to know actually, let's do this one here so we don't have that weird sampling stuff. I want to know what the minimum wind speed and the maximum wind speed was for each station for each day. So whenever your question is kind of formulated like that, where it's like, find something for each such and such, that's a real strong key. If you hear yourself asking your question that way, that's a real strong key that it's probably a group by. So in this case, we said, I want to find, for each day, well, this gives us the day, and for each station, this gives us the station, or for each station day. So we'll need those in the select clause because we want to, see, we need a label for each group. But then the group by here, we just, we're doing 1,2 here just to avoid that typing, but we could spell it out here where we're saying what defines the groups. Well, what defines the group is the name of the station and the date of the report. So any row that is for that station for that date will get included in the group.
Cool, thank you. That's good. All right.
Okay, great.
So I actually have a question.
Okay.
So when we use order by, do we have to use like ascending and descending? Because if not, it's doing the same thing as the group by, right? Because I've seen you use group by and order by.
So, okay, that's kind of interesting. So it defaults to ascending. So I don't type it because it's the default thing, and like I just don't want to type anything extra. But whenever we do an order by, it does always, the default is ascending. Now, as it sounded like you were asking, like if we needed the order by at all.
Yeah.
So the short answer is yes, we do need it. The longer answer is it may work fine, or it may appear to work sometimes without it, because for it to do this grouping, the type of calculations it has to do may implicitly put it in an order that you're looking for sometimes, but you can't rely on it. So the short answer is yes, even if you're grouping by and ordering by the same thing, you definitely do need to specify both.
All right, thank you.
Any more questions? All right, well, I'll hand the stage over to Jake, and I'm going to do a fun data modeling exercise.
All right. Our time's a little bit, I think a little bit off, so we'll probably do this for like 35, 45 minutes and then take a break and go into Q&A. Maybe go a little bit longer, but I want to make sure we get those breaks in. So what I want to wrap up with today is for the SQL is talking about data modeling. This is sort of a whole other side of databases, but it's very practical. And that is, how do you take an idea and turn it into an application supported by a database? There's a lot of ways to build software, and we have a certain technique that we worked on together, Jack and I, but this is just one way of doing it. And I guess I'll just start by saying, do you build a database? Do you design it all at once, or do you design it in little pieces? I think both of those are acceptable ways of doing work. Jack and I have built apps together where we knew the database was going to be really complicated. So we just sat down and planned it out, because we knew that was going to be like the hardest thing. And then there's other projects where the database is not going to be that complicated, or it's going to be, if you're building like a to-do app or something, or a social media app, the data model is probably going to be pretty predictable. So sitting and mapping it all out ahead of time might not be a good approach. Those are both totally acceptable ways to work. But we're going to do a little exercise where we actually map it out and take that approach, because that's something we can do now. So in the same repository, I've got this description of a data modeling exercise. We're going to be doing some behavioral driven development style stories. And we're going to use them to reverse engineer an application that Jack and I actually wrote, which I'll pull up now. Okay, so this is a site Jack and I and some people at HashRocket built a while back called PGCast. It's like a website for basically posting YouTube videos and transcripts of Postgres concepts. So you've got these videos called casts or video casts, and we posted these videos on YouTube that show us demonstrating particular SQL features, and then we included like a transcript and additional information. So it was like a collection of our best SQL tips. So we imagine, like, you dream this idea up, you want to build this application. How do you actually build it? This will become very relevant with your individual and group projects coming up fairly quickly. How do you actually build it? Well, the way that we would approach it is we'd start with something called story carding. The story carding is building a collection of stories. I need to make this bigger. So here's an example of a story. We call our stories features. That was just the language we used. Then we have a title: Visitor Views Most Recent Cast. So this was the first story that we wrote when we were sitting down and trying to figure out how to build this thing. And so the stories we wrote, or the features we wrote, you follow a syntax called Gherkin, also known as BDD. They used certain keywords: given, when, then, are the major keywords, and is an additional one you can use. So what is this story? Well, it was our attempt to try to take a piece of this page and write it out. So someone comes to this site, they see this, how do you describe it? We'd say, given I'm a visitor, we don't really know what that means, but given I'm a visitor, when I land on the PGCast site, then I am presented with the most recent cast. And for the cast image I see, so we have cast image, that's this like giant rectangle. Title, that was the title. Window functions. Author is the author name and description. And then we gave some labels. So we just sat down and we wrote all of these in like a couple of hours with a project manager and a designer. And this is one way to, conceive of an application. So from here, we're going to go through an exercise of actually building the database preemptively. Okay, so I have a board up here, and I took all the stories and I put them into this column over here just so we didn't have to keep toggling back and forth. And we're going to try to imagine what this database would look like. So visitor views the show page for a cast. Oh no, I deleted a couple of these. We will toggle back and forth because I didn't reset this file. Okay, visitor views most recent cast. Given I'm a visitor, I want to stop at each line and say, is there a data representation we need to think about here? So given I'm a visitor, do we need a table and a database just up to this line?
Yes.
Yes. Okay. Tell me why.
You want to keep track of who visits your website somehow, right?
Possibly. Yeah, that would be smart. This all sort of falls under a school of design called Agile. And in Agile, the like winning argument is always like, don't add something until you need it. And right now we're not necessarily saying that we know anything about the visitor. So is it possible that I want to suggest that it's possible we don't need a database up to this line. Do you think that that's possible?
Yes, you can go without it.
Okay, so yeah, there's an acronym YAGNI. Has anyone heard that before? YAGNI. It stands for you aren't going to, well, there's no T in there. You aren't going to need it. You aren't going to need it is a sort of a cardinal programming concept. Don't add something unless you think you need it, because everything you add is future maintenance cost and takes time to build. And if you spend time building every possible thing you can think of, you'll never ship the application. Just an idea. I can see the other side though. So given I am a visitor, let's say we got through this line without needing a database. When I land on the PGCast site, this is kind of vague, but do we need a database on this line? Let's be clear about this. Instead of saying when I land on the PGCast site, let's say when I visit pgcast.com. Now, do we need a database? No, it's just a web page, right? Web pages, lots of web pages don't have databases. Then I am presented with the most recent cast. Okay, so now we have this idea of seeing some kind of data. Probably starting to need a database here. I'm presented with the most recent cast. Okay, so what is a cast? Cast was the name we used when we wrote these stories for these screencasts. So let's imagine making a table. What might this table be named?
Cast.
Okay. I like that. Anyone have another suggestion, or are we gonna go with cast?
Recent cast?
Okay. Interesting suggestion. Tell me more about that recent cast.
Well, because you're trying to grab the most recent cast, you're gonna kind of basically have a cast table, and then you're gonna pull the most recent cast from that table to basically have another table and use that as your presentation kind of thing.
Yeah. So I wanna try to separate the idea of the thing and the descriptor of it. So the thing is the cast. The descriptor of it is that it's recent, but that is just one way that we might be getting screencasts, right? We might have a search feature where we return casts based off of their title or what's in their transcript, right? So I think or we might do them by date. We might say, this one is by date, but we might be doing them by, say, tag. Let's say we add some tags to them, and then we only want to get the screencasts that are tagged Postgres 11. That's another way where it's like, if we just do casts, then the describing thing isn't part of the name. And that's just a way that we can retrieve them. Does that make sense? Okay. So I like the cast suggestion. Postgres convention is a plural for the table name. So there's our cast. So far, there isn't much in it. When you create a table, in most frameworks, you're going to have like an ID, and you're going to have some meta columns. You're going to have like created at, I don't know what it's called in Django, but this is what it's called in Rails. But we just leave those off because unless they're unusual, we just assume that they're there. Okay, so for the cast, I see a cast image. Okay. Now there's something in that table. There's an image. How could we represent this in the table? What might an image be?
A source.
Like, tell me more. Like a source,
The
like
URL.
Okay. Yeah, URL is a very realistic answer. What might that URL be? What might the name for it be?
Image URL, image source.
Yeah, image URL, image source, both sound good. And what might that image, URL point to?
File?
The image.
More or less, like an actual, where on the internet might it be?
Oh, like a directory or, yeah.
Wherever it's hosted.
Okay, yeah, so like where would you host something like that?
CDN.
On a server.
Yeah, server, CDN, S3. So all good answers. I like the idea of putting it somewhere else, right? A CDN is going to serve that up, very fast to whoever is asking for it, versus like on the server where the application is running. Okay, so image URL, we'll call this a type of what would a type be for this?
Text,
Varchar.
maybe varchar
Text,
255.
yeah, sure. Those are both good. Varchar. Is it required? Can it be null?
Yeah, because some will have images, some won't.
Sure. Jack and I are always really, at least when back in the day, I think we're pretty hard on like not letting things be null, but it's okay for things to be null. You just have to, it's another thing you have to think about. If you say it can't be null, then you're going to force everyone who ever puts these in to give it a value. If you say it can be null, then your Python code needs to be able to deal with that. I think that this database was not null, and that's why there's a card for everything. But how would you code around that? How would you code around it allowing it to be null?
Just set a default image, maybe.
Sure. Yeah. Have an image up there that just says pgcast hash rocket, and that's the default. And then you're in the Python layer, you're enforcing it. Okay. No varchar. Okay. I think we've got, so we have a column, our first column that we had to map out. Next, title. Okay. So what is title?
Probably just title again.
Yep. Sure. Type.
Same varchar.
Yep.
And could be null.
Getting into some muddy waters for me here. What's an argument to let it be null?
Honestly, I don't know.
Yeah, that's
I was
okay.
assuming if there's no image, there might not be a title for the whole card or for the whole cast.
That's a fine answer. I think you want to really, a good database engineer you want to be like always arguing for things not to be null, because when everything can be null, then you have a database that's full of null. You know, like make it I think of it like a feature. Do I want somebody who's creating this thing to be able to say there's no title to this episode? It's hard for me to make that argument. I don't know the organization. Maybe there's a great reason why things should be null, but I'm gonna say it shouldn't be null unless somebody has a different opinion.
I think for videos, like no one's gonna watch it if there's no picture or title, right? So if we're thinking about like the user, we wanna provide everything.
Yeah, this is all gonna be pumped into an SEO machine, right? It's gonna be in like meta tags. It's gonna probably be in the URL. Yep, check it out. So the title of this is window functions, and then we turn this into a part of the URL. I have to guess that we did that programmatically, right? So like leaning forward a little, I guess this is the opposite of Yagni, but leaning forward a little, we're probably going to use this title in a variety of places. So that's the easy choice is to say, in my opinion, the easy choice is to say it's not nullable. You can always make it nullable later. It's really hard to take a column that you allowed to be null that has null values and turn it into not null later, because you don't know what any of it's unknown, as Jack said, you don't know what any of those things should be. So it's easy to go back on this decision. It's hard to go back on this decision. Okay. Another thing I'm leaving off here is you can do defaults. If you want to say that this, like when this is created, it has a default value, you can. And you could maybe put your default image URL in there, but I probably would do it at the Python layer where I have an easy ability to change it rather than putting it into the database, but that's a technique. Okay. Author. Let's do description first. Description. Okay, so we need the description. That was the that's this. Hey everyone, today we're going to explore the basics of window functions in Postgres. How do we represent that?
Just description.
Okay.
And then text.
Okay. Is it nullable?
I would say no.
Okay. Could go either way. I like that answer, of course.
That was a good choice on calling it text as well. I mentioned that like varchar and text are basically equivalent in Postgres, but you will see the convention that varchar is like for a single line and text is for something that's like bigger. So.
Nice. Great call. Okay, so lastly, we need to author. We needed to have an author. So that is on each of these casts, it says hosted by Mary Lee. And the person who created the video gets that title. A lot of these are Mary, but then if you scroll down, start to get into myself and Josh and Jack. How do we do that? How do we make an author? Well, what do we need? Maybe that's a better question. In the design, our designer made this nice design and all it says is their name. And maybe it's not a link right now, it's just their name. What do we need to make their name?
Some kind of ID tag?
Like a link to another table?
Yeah.
Okay. That's definitely a way to do it. What would that table be called?
Could be authors, an authors table.
Sure.
Yeah, that's what I was
Persons table.
thinking.
Okay, so what do we need to finish this story? What do we need them to have?
A name.
Name. Varchar maybe.
Yeah.
And I would say don't make that null, because then the whole reason we're adding it is so that we can show it in this page. And if it's null, then I guess you could have Python say #rocket developer, but I don't want to do that. So that's definitely a way to do it. And I think that's the way that we probably would do it, because it's a little future proof, right? We actually got a peek at the designer's design for the next iteration, and this is a link, and it goes to their, if you can see down really small in the lower left of my screen, it's a link to her page in #rocket's directory of employees. So this now knows her name and a URL for her, and also it's clearly not duplicated, or it seems to not be duplicated, because it says the same thing every time with the same link when you hover on the actual name, which you kind of can't. But what's a cheaper, worse way to do this? Let's forget this table. We'll pretend it's not there. What's a cheaper way to make an author show that on a cast?
Maybe just include it as a column in casts.
Sure. We'll call it author name just to be sort of specific. It's Varchar and it's null false. So which one of those is better? I don't know.
Probably
more
have a
dynamic
separate
one.
table. Oh, sorry, go ahead, Porphy.
I think we all said the same thing.
Yeah, what did you say?
The more dynamic one, it's a separate.
Yeah, I think it is a person who's like very hardcore doing agile would say, this is all we need, and you aren't going to need this other table. But everything's a trade-off, and we're always trying to mix doing the cheap, fast thing with like not boxing ourselves into a corner. And also, this is relational, right? We talked about relational databases today. There's a relationship between these two, and now it can scale. And we spent an hour almost this morning like making that argument. So I like this idea, and I think it's probably the right one. Okay, so we've gotten through one story. We've created 2 tables. We just have this on a whiteboard, and later we'd actually build all the tables if we were doing this type of exercise. Next. Almost forgot the most important detail. Visitor views most recent cast. We skipped right past that. Right now, there's nothing that makes a cast the most recent one. And that was a great point from earlier. How do you show the most recent cast?
We could have a date property on each cast, basically saying when it was created.
Sure. Okay, would you call it date?
Maybe like date posted or something.
Sure, date posted. I like that. as I said, in Rails, the convention is to do like something at. So I don't know Django ORM, but you probably want to line that up with whatever ORM you're using. Something that a lot of people think of when they do this the first time, and it's, oh, I see a hand up.
I wasn't trying to interrupt you. I was just curious as far as when you're creating this, like sometimes you'll have some automation with the tables where they'll have like a date creation on there that's automatically done.
Yeah.
When it comes to doing these types of stories,
Yeah.
how much discussion is there as far as their ability to go in later and change like a date posted, or just leave it as whenever you create it, that's what it is, and just leave it at that?
That's a great question, and it's completely in line with what I was just saying. A lot of times when we do this exercise, the first answer that will get thrown out there is to use those meta dates that are on the table already, that are we hid from here. So there's a created at and there's an updated at that are just part of Rails. I'm going to learn what those are in Django the next time I teach this. Doesn't really help you all, but often people say, well, let's just use one of these. Let's use created at. Whatever the most recently created at one is, that's the most recent one. These columns are, you can update them, you can change them, but I think the smart thing to do is to treat them like they're not something you can ever touch. You let Postgres, actually, does Postgres update them if you update them in SQL, Jack? I don't know.
No, it doesn't. Not unless you set up a trigger.
Okay. You let your ORM mess with these. Your ORM puts the timestamps on them when they're created, and it updates the timestamps when they're updated. And a smart strategy, in my opinion, is to not ever mess with these, to just let the ORM do what it wants to do. But this this creates a problem, which is, well, what if I want the most recent one to not be the most recently created one? That's a pretty realistic scenario. Like imagine when we made this database, we just dropped all of these pre-done exercises in there, and they all got created within like a millisecond of each other, a second of each other. Well, created at is meaningless at that point. They're all, the order that they were created at is essentially random, and all within a very small amount of time. So using created at for that isn't very good. And also, if you want to change the order, then you have to change created at. And this really has meaning. This means something different than what we're doing here, and you don't want to be changing that. So it's kind of cool that that wasn't the direction that we went this time. But I would just say it's better. It's preferable to say posted at, and then have all three of these, and this is the one that you're altering when you want to change the order. Yeah, so you're ordering by this. This also gives you another really cool ability, which is you can set posted at in the future. So this is what a lot of blogs do, is you say, I want to publish this post in 2 weeks, then they'll set posted at in 2 weeks in the future, and then the first time someone requests that web page after that date is passed, they see your post. That's not something you could do it with created at, but it would be unwise to say this record was created 2 weeks into the future. Is kind of a bit of a head scratching idea. And the same with updated at, but posted at, I think there's nothing wrong with saying it's being posted at 2 weeks into the future. I don't have a problem with that. So what is our type on this column? Is it posted date? Timestamp? Time zone maybe, because that's what we're doing.
Yeah. Yeah, I'd say timestamp TZ.
Of course. Can it be null?
No.
No.
Yeah, I'm not sure. Here's an argument I'd make is maybe I want to have maybe I want to have posts that aren't posted at all. Like I guess I'm kind of thinking ahead here. But in a version of a blog I wrote once, we allowed posted at to be null so that you could have like drafts. A draft is the only thing that makes a draft is that it doesn't have a posted date. But I'm thinking ahead, and let's go with let's say it can't be null for now. And then if later somebody wants there to be drafts, then you just change that, and every new post can be a draft. Okay, so now we have a way of saying what the most recent post is. In Rails, you'd say like cast, order posted date first or something. Or maybe there's a better way to do that. But you can do it. And you can order the whole list by posted date, which is coming at us quickly. Okay, so now we have the first story done. The benefit of doing work this way is like then when you start to do this, you just can make one giant series of migrations, or one giant migration that does all this. It's pretty brilliant if you get it right. Okay, next, visitor views list of recent casts. Given I'm a visitor viewing the home page for PGCast, well, we basically just went through this and saw that there was no special database requirement to that. When there are recent casts, okay, so we have some records in the database. Then I see up to n number of recent casts as dictated by design. Okay, so we're showing some of them. I think we can show some of them using just Python. And the videos are sorted in descending order by date. We just added a way to do that. We can sort their order by published date now. And for each video, I see thumbnail, cast image. Okay. This is, I guess, the same thing as the image. It's like a smaller. Oh, okay. So that's all these things down here. They have a smaller image. Probably image URL is going to be okay for that. What do you think? Do we have to do something else to have a smaller version of the image? Say again. Oh yeah, I probably there's a chat. Okay. Question. Difference between a visitor and an author. Did he already mention authentication and if it was necessary? Great question. Authentication is something you build on almost every app. I find it very boring and frustrating to build every time. But it's like so core to web applications. Is there a difference between author and visitor? Right now, we don't really know how any of this data got here. So I don't know. Author is somebody who made the thing, but does Mary Lee have a relationship with this application that's special? Like, is she authenticated? I don't know. I certainly don't think our stories have spelled that out yet. Visitor though, I don't think we need to. So you can track your visitors without them ever being logged in, right? Google Analytics or, there's like a whole bunch of techniques to do that. Most websites are tracking a lot about you before you ever log in. So we don't have to necessarily have them logged in to be able to try to understand something about them. So I think I'm kind of rambling, but so far I don't think an author is something that is like in the application as a role yet. And I think visitor, anybody who comes here, this is a public free website. I don't think anyone who comes here is authenticated, if that makes sense. Okay. Do we need to take a break? It has been almost an hour. Would a quick, I feel like there's a little more of this exercise to do, but it's been a while. Can we go for like 10 more minutes and then take a break? Or should we take one now?
I'll say take a break now, just kind of a little refresher. I'll come
Okay.
back refreshed.
We'll take 10 and then we'll come back and do this for about 15 more minutes and then we'll go straight into Q&A if that works. Okay, see you in 10. Okay. Let's pick up. And we'll do this for about 15 more minutes, and then we'll go into Q&A. So I think we had gotten through another story, or we were close to getting through another story. Oh, we were talking about image URL. I asked a question about image URL. Could you make both of these screenshots with the same URL? Do we have?
Yeah, I think we would be able to do it because you would just change the CSS to make it fit like that size div.
Sweet. Yes, sounds good. Okay, so I think we've gotten through another story. Title, author. Yep, I think we can do all that with our current set of information. Okay, visitor views the show page for a cast. Show is the the read convention for web apps where it's like this is the individual page for each one. So what we're doing here, this would be, a lot of people call this an index. They would call this a show page because it's the individual page. So let's look at that. Given I'm a visitor viewing the landing page for the cast. Okay, this wasn't very precise language. The show page for a cast. Oh, this was the index. Viewing the home page. When I click on a cast, then I am taken to the show page for that cast. And for the cast, I see a video player. Okay, so for a video player, how do we do that? Let's look at the example, what we did here. Okay, so this is a YouTube embed. So for that, all you really need is the YouTube ID of the video. And then everything else is just code that's in your HTML. So how could we make that something that's in the data?
Just put in YouTube ID and have it be equal to the integer of the YouTube ID.
I love it.
Would you make it an int or a character? Because if it's going to be rendered in HTML, right?
Those I like all the suggestions. Is
you can always convert it, I guess, on the front end if you had to, but you know.
Well, there's another concern I have is when you yeah, so let's actually look at what a YouTube ID is. This is
I'm a little confused as to why you wouldn't take the whole URL instead of just the ID.
well, let's think about that. Here, this is not me logged into YouTube. So here's the URL for a video. So we got to assume that the V equal is the ID. So let's take that back over here and think about it for a second. First of all, what kind of type is going to support this? Well, let's tackle that original question. Why not have the whole URL? Why not make this YouTube URL?
Because you only have to, it's going to be the same for all the videos except for that one part, just the ID.
That's true. That is true.
Maybe the URL structure changes one day, but maybe they still make it to where the way they play the videos, they still assign the ID that it's been given, even though they might have changed the URL structure a little bit.
Yeah, that's another good point. We can make a pretty bulletproof assumption, I think, that this is never going to change, but this might change. They might change the way that they, do their domain. They might, throw something in there like that, or you might be in a different country. And the way that you view YouTube is different, and it might work okay. It might redirect you to your country's version of the site. Another thing is that sometimes with videos, you end up using it in a bunch of different ways across your site. So you might have an embed, which, by the way, the embed URL is a little different than this. I don't remember what it looks like, but it's like, it's something like this. But not at all like that, but something like that. In other places, you might want to just show the link. So like you might just want to actually paste the link out and have like a little copy button next to it so people can copy it, or you include it in the transcript so that people who download the transcript just get a link to the video. There's a lot of different things you could do with this thing. So a way to kind of cut down on duplication and also to make it like as future proof as possible would be to say like YouTube ID. And then it's like, I can construct any URL I want. If in one place I want to put it at the end of this, I can. And if another place I just want to show the entire link completely. Oh, and also I want to put a query parameter on there that says like from HashRocket that they somehow honor. I can, but you kind of keep yourself real fluid by just using the ID. Does that make sense?
I think timestamps is a really big thing because you can also put timestamps at the end of the URL also.
Right. What is that? S?
I think so. I can't remember the exact letter, but I know because you'll see a lot of videos, especially longer videos, you can just click certain placers and it'll automatically put you to that point in the video.
Yeah. Right. So maybe inside of picture this, inside the transcript, we get down to here and we're like, this was a really long video. We get down to this point and we're like, if you visit this part of the video, you'll see this thing. I didn't talk about it for very long, so you might miss it. And then I can link to that. So I'm reusing over and over and over again. By sticking with this design, I'm reusing the YouTube ID over and over and over again. And I'm not trying to like pull it out of a string of YouTube URL. I just have it and I can like interpolate it into any URL that I want. Okay, so does that make sense, or further questions or thoughts on that?
Yeah, that makes a lot of sense. Thanks.
It's all trade-offs. There isn't really a right answer. But there are answers that are going to be better and worse going forward, I think. YouTube ID. So we can't use a number for this, right? That's not going to work. It has a V in it. Another problem with numbers, I was going to think of this depending on the status on the formatting of them, is like if it starts with a 0, let's say that this is the number and we coerce this to a number, that 0 is going to go away because our database doesn't like that. So you're going to lose that 0, but the 0 wasn't an actual number 0, it was a part of a URL, but we didn't have that that problem. So we can say varchar, and I'm going to say null is false on this, right? This is the whole point of the website, is to show these videos. What good would a cast be if there was no cast or no video representation? Okay. So that gets us through. We'll go to the end of this this story, I think. We have a video player, we have a title, we have an author, we have a description, and we have a tag list. Okay, this is where we might have to have something different. So when we conceived of these tables, we had these tags, and we were going to tag every post and say, this is Postgres version 11 and it's window functions and it's expert level. So we want to have tags on there. How could we have, let's just assume that we have this tag, Postgres version 11. How could we have tags be associated or attached to the window function?
Could you make it a text? Still, some posts have a lot of tags, I guess.
Yeah, let's assume we want to have more than one possible, right? We're only showing one right now, but let's say we know we want to tag this special video we're making Postgres version 11 and expert. How could we have at least 2 tags?
Would you want to make a whole new table for tags and then use IDs to list on that casts table?
Yeah, that's a great why did they put this all the way down here? Come on. Oh, shoot. That's a great question. I'm not sure. That's what I'm trying to figure out right now. Let's imagine that tags. What would the tag need to have to be able to support this? It's doing something, right? It's like, it doesn't link anywhere. It doesn't look like a link. It doesn't go anywhere, but it's got some words. So how could we represent those words? Back to following this example with the tags table.
Assuming that there eventually is going to be some requirement that by tag, you're going to look up all the casts that have that same tag as well, which just makes it easier to condense down your tags to do your searches.
Yeah, that's why that's the main argument for doing it this way. Is like we know that we're going to want to see all the posts with the tag maybe. If you want to do it, if you think you're going to want to do that, this is the way to go. But just to finish this table, what information does it need to be able to like at least support this story where it's like a little box here with some words in it?
A name.
Okay, name. Make it a string too. Null, false, maybe. So this alone would support what we're doing. A simpler version of this would be like tags on the table here, and this is an array, which is something Postgres has. And I don't know if you say like array of type.
And if you have your tags in a separate table, multiple tags could be associated with multiple posts, right? Or
yeah,
videos.
Right. So I'm not going to say that. Let's say this is an array of type string, null, true. I am not going to say that this is a better solution. I'm going to say that it is a solution, and they both have an argument behind them. The argument for doing it this way is that you might never be planning to do anything ambitious with these. Like maybe you just want to say, hey, this post is Postgres, this cast is Postgres 11 and it's expert. And then the next time you do this is like a year from now, because we're not posting the site very much, and you say, this one is Postgres 13 beginner. And you don't care, you don't care if there's ever been a Postgres 11 tag before, or a Postgres 13 before, or a beginner tag or an expert before. Or maybe you type this one time like beginner without 2 N's, like that's bad, or beginners, had it here, a correct word. Maybe you don't care. Maybe you don't care that in 2 years you tag something beginners, because maybe you're never going to have a page that sorts by the tags. We certainly don't have that in this list. Now, is this every story we're ever going to build for this app? It turns out it actually was. We didn't really build it much farther than this. We never actually built searching by this. So you can't click on this. There's no tags page. And that's all that ever became, because we ran out of free time to work on it. So was it wrong to do it this way? In this case, no. And in this case, adding this table would have been sort of for nothing. Again, like, I'm not saying one's better than the other. I'm saying that, like, they both have a case. Does that make sense, or does anyone still have an issue with that or want to talk more about that?
I think it just really boils down to implementation, I guess, right? I mean,
it does, but what the point I'm trying to make is that there's a cost to doing more complex things. Have a cost. This is a really simple example because we're talking about the difference between adding a table or adding a string, a column. It's not the best example to illustrate it, but in real web development, sometimes the simple solution is this, and the complicated solution is 2 tables, or a table with 5 columns in it. And you have a real testing culture, so you have like unit tests behind everything, and sometimes it's much more complicated down this road. So I guess I want to challenge everyone to really think, when you're having a moment like this, would this be good enough for what I want to do? If the answer is no, and most of the time or lots of the time will be, then great. But it's a good exercise to think about it, because we want to ship fast and cheap. We don't want to we don't want to ever add something we don't think we're going to need.
so in terms of like search and just like, I guess in performance wise, would it perform better? Say if you did create that functionality to where you would show all posts by a particular tag, would it perform better if you did take the tags and create a separate table for it and then associate posts with each tag?
Well, it would be much easier to implement search, I think.
Okay.
Like it's.
Can I jump in on this one, Jake? This is
Go for it.
This sounds like a fun one. So Postgres has some fairly in-depth array support. So as far as searching for like all casts that have this tag or these 2 tags or something like that, it would actually be far easier to do that in the array version. Now, as far as would it be better performance one way or another, that one is kind of hard to say as well, because Postgres also has some pretty good indexing strategies where, in theory, the multi-tables would often be better, but in practice, Postgres's array indexing functionality is really good, and it may be a little better there. Another thing with the tags, though, is if we were really going down this entire path, Jake mentioned sometimes this is 2 tables. I think this would be an extra 2 tables, because we would have a tag that lists these are, or we would have a tags table that says these are the tags. We would have another table that joins tags and casts. And all that join table would have is the ID of the cast and the ID of the tag. Could be, you'll hear this terminology as a many-to-many table, or a has and belongs to many in Rails speak. And it gets really interesting, because from the pure, like, especially like academic world of like, normalizing data, we haven't even talked about that type of concept, but you'll see that in the academic literature. Like the multiple table thing here would be considered the better one. But as far as the complexity in actually using it, if you want to select from the version with just the tags array, you write one query that selects from one table. You have a where clause that says, tags array includes such and such. If you want to do that for the multi-table thing, you're now joining 3 tables together. if you want to say, give me all the tags along with the names of the casts, now you're probably doing like a subquery, or you're having to do, 2 joins and a group by. If you want to do something really interesting, like find me all the casts that have the tag Postgres 12 and the tag expert. Well, in the join version now, well, there's a few ways you're doing it, but one way would involve having to join with each of those tags and tags cast table twice, because you need to join it for each one. I mean, there's a way around that. But anyway, I guess the point I'm making is when we talk about the better way, in theory, being a lot more complicated, it really can be a lot more complicated. It makes a pretty simple select statement into a join with, or a select with 3 tables involved or more. And that's, yeah, there's definitely assets and liabilities to both sides, put it that way.
Yeah, one of the core ideas of Agile, and I think you'll cover this a lot more, but one of the core ideas of Agile is that you want to build an application so that you have a finished thing, even if whenever you have to stop, because in real software development, stuff ends. Teams run out of money. People who are working on something leave the company goes out of business, or the company gets bought or acquired, and everything just changes. And when the main argument for Agile, I think, is that if this was the last story we ever did, either of these would be, you'd be able to walk away having done either of these. But if it was the last story we ever did, would this have been good enough? Probably, because all the optimizations that this was being built for never happened. In Ruby, you'd say tag.casts, and that would give you your index page of all the casts for that tag. But we never built that page because we ran out of money and everyone moved on. In the case of this project, Jack and I were doing it in our free time, and we just suddenly didn't have any free time. So it's not this argument isn't just an academic argument of like, well, what's simpler? It's like, what's the likelihood that we're ever going to actually build a page that does that? And in the case of this app, we never did. But it's a finished product as far as we're concerned. It's on the internet, and people, like lots and lots of people have viewed these videos. So
does that help when then you're creating, like you say, your stories and your sprints and everything, when it comes to like prioritizing like different features and things that you're eventually going to develop? So if that was like a feature that was not as high as a priority, would that go into how you would design?
Yeah, exactly. So like we had designers at HashRocket, and they would make a design that looked just like this, right? And they would include all of the initial things that we'd story carded. But when we write the stories, we're like literally sitting in a room just writing these up together, and then we get to the bottom, and it's not a very long. There's like 100 lines in this, so there's like 10 stories. We get to the bottom, and then we ran out of story carding time, and we finished. And then when we work on them, we upload these into a project management tool like Jira or Pivotal Tracker, and we prioritize them. So we say, this is the first most important, this is the second most important, this one you can't do it until you do, this is the first one you have to do. The order of these actually matters. And then, in true agile tradition, you just go through them until the project is done. And that's what I think you'll do with your individual and group projects, because you have to have like stretch goals and like things that you maybe want to get to if you have time. You're never going to get to everything. There's like always more that you could do. That's how I think product managers think of software in a way, is that there's always another story to do. So it's all about prioritization. You can only just do the next thing that's most important. So yeah, I think that's a great observation.
Another angle on like how we decide what to do is it's how likely are we to change our mind about this? And how expensive is it going to be, if we're wrong or we have to change our mind? And that informs like how long we need to think about it. Like one of the decisions we made earlier was to say that like the title could not be null. Well, if for whatever reason we decided to change our mind on that, that'll take us about 15 seconds to change. So no problem. If we changed our mind the other direction, we allowed it to be null and we changed our mind there. Well, if we had a bunch of null titles, now we need to go figure out what to do with them. So it's more expensive to change direction there. Another example is like with the authors table. We could have just gone with author name. And that for the stories we had, that would have been fine. But if we then decided, well, now author needs to have something else, which means it really needs to be a table. Well, how hard is that going to be to change? Well, now we need to create the table. We need to migrate the data. We need to deduplicate it. So, we have a cast that has 3 people by the same person. We only need 1 record in the author. So we need to deduplicate it. We need to change all the places in the code where we've considered author name just a field. Well, now, maybe we write a helper method or, something like that. But in theory, we need to, traverse to a different table, depending on if we're using an ORM or not. We need to think about, oh, now I need to rewrite the SQL here to join to this new table. The ORM might do it for us, but now we're always doing 2 SQL queries instead of 1. That change potentially becomes pretty expensive. So maybe we don't need the authors table now, but realizing if we do, this is going to be an expensive change to make. So we go ahead and make it with that in mind. And there's that constant tension, especially with tags here, because it's so easy to do the array version. But, the multi-table version is significantly harder. Are we ever going to change our mind on that? If we do change our mind, how difficult is that going to be to, change all the code? So yeah, how likely are we to change our mind and how expensive will it be if we do it?
Yeah, that's a great point.
Are those conversations that you're having with the product manager and product owner as you're going through doing this stuff? And then like how much of the customer aspect of things weigh into what we as an engineer would think is academically amazing versus, balancing all of the things between cost and all that stuff on the back end? Like how does that weigh into those decisions?
Yeah, I think I think a lot of it is stakeholders. Yeah. I think some of it is, so when we do story carding and in my work now, which is a little bit different team organization, I'm always like the programmer in the room. So I'm the person who knows, I'm the person who knows that this is even a problem. No one else would even, like a non-programmer wouldn't even think of it this way. But I think a lot of it is just knowing what you're doing. So when we were building PGCast, we were doing something on Friday afternoons. We knew we had limited time to get it done. And we knew that we were going to eventually, those Friday afternoons or those Fridays that we were off on side projects would eventually get filled up with work. We were at a consultancy, so we had just some time to kill because we didn't have consulting work. We knew, I think, in that environment, you're like, speed is our friend here. We're probably not going to make the most complicated app in the world. We need to just get this shipped because shipping is something that a lot of apps never do. But if you're on a company, like a profitable company that's building something for the long haul, then I would go the tags table route probably, because I'd be like, I don't know what they're going to want me to do with these, but they're probably going to want me to sort by these at some point. So what's the future-proof thing to do?
Right. And another aspect of that is it's not like we get the stories, or as the developer, you get the stories like set in stone. So like typically for something like this, like I would want to read all the stories up front just to get the broad scope in my mind. So like if I read this story and I know that, well, 10 stories down the line, they are asking for search by tag. Well, that's good to know. So you do want to know that. But in the same token, the stories aren't set in stone. So like if I saw a story that said, I have a tag list here, and I read all the other stories and there was nothing else about tags, well, I wouldn't just say, okay, I don't need search, so I'm not going to build it. Or just say, well, I'm sure they're going to need search later, so I'm going to build it. That's when you ask the stakeholder, hey, you talk about tags here, but you never actually use them anywhere. Is there some missing scope here? Do you actually want stories for searching by tag?
Right. And that's a great point, because sometimes a decent amount of time the stakeholder will be like, oh, we're not even doing that anymore. You know, like that came up in story carding, but we don't really want that. Just forget about that. And now you've just sliced like hours of work off of your project.
Is it really like the project manager is supposed to like really push back on stakeholders sometimes? Like, hey, those are great things, but in terms of like the scope of the project and what we're building, maybe I'm trying to, because I've operated in this capacity a little bit. I'm just trying to, I can't fully remember because I've worked with stakeholders before and just, it's like, these are all great ideas, but in terms of the mission and what we're trying to accomplish, you know what I mean? We don't necessarily need all these things or these features, or this is not as high as a priority as you may think it is, or
there's like, yeah, no, there's been so much like interesting writing on this subject. A huge, like the Lean Startup by Eric Rice, you know, the concept of an MVP, the minimum viable product. It's you know, like I feel like, to me, like the biggest threat to like any code project is like not shipping. So many things don't, so many things either don't ever release at all, or they take way longer than they plan to release. And speed, you know, speed is a virtue. It's not the only virtue, but you want to get your stuff out there. You want to actually release it and get it in front of customers, so you're getting real feedback and you're iterating on the important things rather than just imagining every feature that a customer might want. So I think making decisions that like prioritize like launching and iterating are always going to have like a place. So yeah, a project manager who's like trying to have everything is like, you know, not like needs to cut some scope for sure.
And it's not even just the idea of like pushing back, it's just making sure they know what this is going to cost. If they mention something like, oh, well, you know, the implications of that are this is an extra month of work, we're happy to do it, but just so you know, this is an extra month of work.
Right. Right. You can make, as a programmer, you can bring your expertise and say like, this is, here's the complexity of this. And, you know, here's why we might want to do that next year. And we might want to do that after we launch. This is why this is an MVP. Like tags on this app is not MVP. I don't, and we probably launched without it, or maybe we launched with this super basic version, but you know, we could have released this without this, and I don't think anyone would ever care. As a programmer, you can help inform that conversation by saying what it will take it to actually do it.
All right, and another like kind of like really interesting thing about this data modeling is this applies even if you're not using a database. You'll go through this process, something like it anyway, even for just your regular program. Like, what is the data that your program uses while it's running? And or if you're not using a traditional data store, like Jake, if I remember right, like we used Middleman for this, didn't we?
Yeah, the original version of this site was statically generated, no database.
Right. So I don't know if y'all have seen like static site generators, but they'll use just, you know, some template files, like some YAML files, perhaps some JSON, something like that. And then they compile that into HTML. So there's no like runtime application or database at all. but the interesting thing there is that data model still exists. You know, there was a template that has a spot for the author and has a spot for the YouTube ID and has a spot for the title.
I've done it with data like Power BI and like not even really databases, even pulling just spreadsheets and modeling different spreadsheets together to build visualizations of the data, you know, so it seems very familiar to me, just how the different relationships within the data exist. And
right. Yeah, the data modeling stuff is much, it's generalizable far beyond just, you know, a SQL database.
Well, why don't we stop there on data modeling, and happy to go into Q&A now. I think this is, it's weird because we've been going for like 45 minutes, but we'll do like 15 minutes or so of Q&A, or talk until no one has any more questions. Yeah, open the floor up. Anything you'd like to ask myself or Jack about coding, tech in Chicago, veteran stuff.
I have a quick question.
Yeah.
So I saw you're using an array in your the data modeling. Is that something we normally would use within our SQL, just in general at all?
Yeah, I'll take that one. Yeah, we didn't get into it because it's a slightly advanced like Postgres feature, but Postgres lets you have as a column type an array of things. So you could, just like we have text columns, we can have a column that is array of text. And it is like, it's a little, some people get a little nervous about it because it does violate like the normal forms stuff of, you know, again, the academic database stuff. But it's really, really useful. And yeah, it's totally built in Postgres, works great.
Okay, thank you. So it's more towards like advanced level Postgres thing.
Sorry?
Oh, I was just saying, so that's more towards advanced level Postgres, SQL and stuff.
I mean, it's not like super hard, but you know, it's not day one either, which is, you know, we were basically doing like a day one introduction here, but yeah, I mean, if you were curious in it, I mean, you know, you'd probably pick it up in just a few minutes looking at the docs. It's just another data type, and just like any of the other data types, it has like its own operators and whatnot.
Okay, thank you.
So I'm kind of curious whenever you're going through these stories with any clients or whatnot, and you're running into situations where, you know, you're not necessarily going to have the full, what are we doing after this particular stretch is done. But when you're starting to see where if you don't design your database for kind of normalizing it more, I should say, and incurring that technical debt, how much of that does actually push back on the client, say, hey, you should probably think about it, versus we'll just get this done and then charge them more later?
Yeah, I mean, there's a saying about programming, you should always code as if the next person who finds your software is a psychopath who knows where you live. You should, I mean, you want to build an application that you would want to maintain. So I think the complexity of doing something like with multiple tables versus a column is, the difference is significant, but it's usually not like days of work. It's like one of the solutions takes 20 minutes and one of the solutions takes 30 minutes. So a lot of my work is like being paid to make the decision myself, and like being paid to like defend it and explain it. I don't go back to the stakeholder on like every choice like that. I might go back for like general direction and to say, hey, do you think we're going to do anything with these tags or not? But I don't really like ask for permission on stuff like that. I just try to I try to do the best. I try to make the best choice that I can given what I know. It's like that Sandy Metz quote from my talk this morning. We'll never know less than we know right now. You know, at the beginning of a project, nobody really knows anything. So you're just trying your best to make the decision that's gonna be the least painful in the future.
Right. It's definitely, there's definitely like an art to it, and it's more of a judgment call than there being a hard and fast rule. But like personally, like for the stuff of like an author's table, I don't think I would ever just use an author name text thing. I mean, just based on experience, you know, we're just like, okay, there's going to be something else. Tags, I probably would just go for the array of text first, unless I knew this is going to be at some extraordinary scale where there might be some sort of, you know, performance implication there one way or another. But just for simplicity's sake, I mean, I would almost always just go for the array there. But it's not that one is right or wrong. It's just like, okay, I've done this for 20 years and I got the gut feeling that it's probably better this way. But yeah, and as far as the stakeholder, you wouldn't really bring that to their attention so much as that's, you know, kind of what they're paying us for. I mean, the only thing I'd really go back there is maybe, you know, that idea of, okay, you mentioned tags. Is there more features here? And to kind of a hint to see what features they're looking for. I don't really go back for technical implementation details.
All right, guys, any last questions for Jack and Jake here? All right, Yelan says thank you to you guys in the chat. I will echo that, and I assume our students are very thankful for you guys giving your full day here. We really appreciate you guys coming in. Jack and Jake, thanks for doing this as always. I think our students learn a lot. I feel like I learn something each time we go through this, so definitely appreciate your time, guys. All right, yep, Jack and Jake, we'd love to have you guys back for next cohort, so we'll reach out then, but all the best to you guys for 2022 ahead.
Thanks for having us.
Thanks,
I really enjoy it.
Thank you very much.
See you, Jake.
Thank you so much.
All right, class. So that was our in-depth SQL workshop. Hope you guys learned a lot. I know that's a lot to take in. But we're trying to give you a good foundation for SQL. And Jack and Jake are great resources and very knowledgeable, as you guys can tell. We're not going to keep you guys much longer. I know it was a long day of lecture, so we're going to wrap up here and then call it a day. You do have some assignments for today. I think there's 2 tutorials that we're just going to have you go through. Get as far as you guys can in them. Don't feel bad if you can't complete them, but try to apply the material that we kind of learned yesterday and maybe some of the things we learned today. And you might need to Google. Again, we're not expecting you guys to know everything right off the bat, but hopefully you guys can write some queries and get through the tutorials tonight. With that said, is there anyone have any questions about anything on your mind?
I have a question. Is there an assessment this Friday?
There is an assessment this Friday. Okay. Great question to ask. Always good to know what heads up. So it will cover basically the last 3 weeks of material. So it's going to have a HTML Django portion, I believe, and then there's also going to be a SQL portion. So the stuff we're learning this week, it is short turnaround time, but we're going to ask you to just create some tables, write some data that goes into the tables, and then do some simple, maybe moderate queries. Using join. So I don't know how much we've talked about join yet, but you should be able to write a query that joins multiple tables together. We're going to see more of this tomorrow. So again, obviously a couple more days material, but hopefully we can get comfortable with SQL by the assessment. Any other questions out there?
Yes, thank you. I just have one follow-up question. So we still haven't received my assessment. I still haven't received my assessment back from the second one. So I don't have feedback going into the third one yet. Will we have it guaranteed by Friday?
I cannot guarantee that, unfortunately. But I will say there's basically no overlap. So okay. Assessment 2 was OOP. OOP is not going to go away, but that is what assessment 2 was. This is just me strictly writing an HTML page with Django and having some functionality there, and then writing some SQL. So no OOP that I can think of should be present on. But fair enough that you might want feedback just in general. We're hoping we'll get those back to you guys soon enough.
Is the assessment for Friday timed at all, or is it like the last one where we have over the weekend?
Yep, yeah, you'll have the weekend to do it. Great question. So yeah, I think it's only the first assessment was the time one. The rest of them will be take home / weekend assessments. So I think this one's a fun one. It is, again, assessment 2 is probably the hardest assessment. This one is not as hard. It might require some amount of time, but I'm assuming the students will do overall better on it. Not to say that you guys can do so great on assessment 2.
Can I see you after class for a few minutes, Ankur?
Yes, Sanjay, sorry, I was supposed to connect with you at lunch. Yeah, well, I'll message you on Slack. All right, guys, I know that was a long tape, but again, take your time with the material tonight, and we'll see you guys tomorrow at 8:30. All right, see you guys.